to do. Don't rely on it at all. Always use your set statements. So these are the 3 common ones.
Mine still fails every time I try to do the storage engine.
Same thing, the set statement?
Yeah.
And you know what, I did it, I thought maybe because it was your default and it was doing that, but that's not the case because I changed it and then I still have the set statement and it is fine. So I don't know what is happening. Did you try to Google it and see what you,
yeah,
why?
It didn't help.
It didn't help? I didn't know because I tried that. I thought it doesn't make sense. If something is already default, even if you set it, you shouldn't complain about it. Like it shouldn't be an error. It could be a warning, but not an error.
Yeah.
That's an error you get, right?
Yeah, it fails.
It just fails.
Yeah.
Yeah, so I can keep that in mind, but I don't know, like if Google is not helping you anymore, then I don't think I can. Like, but I tried that, making it default. Okay, so what I'm working here are with 2 tables, of I think 3, but we'll look at the tables. So, and as we say, as I go through tables, please ensure that they're all in the 3rd normal form. So the first table is really easy. It's a table about toys, and it says toy ID. Every toy has a toy ID and as a toy. So if you remember it from last week, we were working with toys and boys, and that's from where it is coming. Now, again, I mentioned, as I said, I've taken this from websites, and you will notice that they usually have this int 11 in their data types, right? Why? This is nothing to do with storage at all. I've mentioned this before. It is just how it will be printed. So it says by default, it will take a space of 11. That's what the 11 means. It has nothing to do with storage at all. Keep that in mind. So it's kind of misleading. So I usually don't use it with my ints ever, but I mean, that's what it means. Then I insert some data. I insert some data into my table. If you want, you could make this an auto increment key, but I have just chosen it not to be made an auto increment key, and therefore I have put in values myself. We've already talked about what works and what doesn't work with auto increment. Then I have another table. This table, if you see, is about boys. So kind of odd, but every boy has a boy ID. We need a primary key. So it is in the 1st normal form, it is also in the 2nd normal form, and it is also in the 3rd normal form. 2nd and 3rd kind of automatically default if your primary key is only of a single field. Because remember, 2nd and 3rd normal forms are talking about non-key attributes and composite keys, but they only have a single field. It's only a primary key of a single field. So if it is in the 1st normal form and the key is single, you can kind of automatically say it's in the 2nd and the 3rd normal form. So that's about boys, right? So again, some boys, some names, and some IDs. Every table must have a primary key, must. So if you can't think of anything, then the best way is to put a auto increment info. That's how people work. That's how we work, right? Okay, and the 3rd one now is, again, if you've missed class last week, or if you have any questions, you can ask them now, because after this, I'm not kind of repeating it because we have to move forward. So what it is saying is that the 3rd table, which is the connecting table. So usually what will happen, you will have data, you will have entities like boy and toys, or boys and whatever, right? You will have entities, and then there will be connecting tables between these entities. And here come relationships. So if you kind of think of it, you have a boy table in which you have a boy ID and the name of the boy. You have another table which has the toy ID and the name of the toy. And now you want to connect these tables. The connection is this boy has this toy, is what you're saying, right? This boy has this toy. So you'll make a connecting table. And that will have, it has 2 fields, one a toy ID and the other the boy ID. So I'll write boy here just because this is easier on this side. So the primary key is this, and is the combination. Now kind of think of the foreign key constants. The foreign key constant says the value in this field must draw its value from this field. You can't have something here that is not here. This is a constant, a rule, and it's called a foreign key constant. We call it a foreign key constant. And what is a foreign key? A field whose value is drawn from a column in another table where that other table will have that as a primary key, right? Similarly, toy ID is drawing its value from toy ID. Now let's look at relationships. As soon as you have more than one tables, there will exist relationship. Now in relational database, there are a few kind of relationships. You have a one-to-one relationship. Every record in one table has only one corresponding record in the other table. Another relationship that can occur is one-to-many. And we see that here. This toy, this boy ID, suppose this boy ID is 1. This value may occur many times here. So boy 1 can have a toy 1, boy 1 can again have a toy 2. So one can occur many times. So this relationship is called one-to-many. One record in one table can have many corresponding records in the other table. You can write it a few ways. You can say 1-m. You'll notice also, we'll do ERD diagrams also. You'll notice sometimes it is also written as, it's called the crow's feet. So from one, you're going to many, right? That's another way of writing it. So there are a few ways, whatever makes sense to you, you can use it. I'll show you how MySQL Workbench works with it. You can choose 1m if you like. You can choose one crow's feet, it is called. Many means a crow's feet, or it is, there are a few designs, a classic and so on. So now the relationship between this table, and sometimes it is also shown this way. You can pick it up from here. You can go to the boy ID field here. You can write 1 here and you can write m here. This tells you that there is a 1-to-m, one-to-many relationship between the boy ID field, between the boy ID field and the boy ID field here. This is the second type of relationship that will exist in tables, between tables in a database. Then there is a third type of relationship that may exist. And similarly here, this toy ID is related to this table with 1-to-many. So you write 1 on one side and you write m on the other side, right? If there was a 1-to-1, you would say 1-to-1, 1 on both sides. And a third type of relationship that exists between tables in a relational database are many-to-many. I don't see anything here in this table, but when it comes, I'll show it to you. Again, you can say mm, you can draw crow's feet on both sides or whatever it is. Okay. So now, as I said, there are more normal forms, and these relationships are actually identified or not identified, unidentified, and this is quite a bit of, you could say, a little more advanced than what we are doing in this course. But as I do it, I'll mention it to you. If you can remember it, good. Otherwise, when you need it, it will come back. Okay. Okay, so we will learn how to also draw ERDs, entity relationship diagrams today. It's like class diagrams in Java, a diagrammatic representation of what I'm trying to show. So we'll draw those also. We have to learn how to draw those. Why? Because they then help us to understand our relationships between our tables. Okay. Okay, so this third table is a connecting table. It has a boy ID, which is again an int. It is not null. And the constraint is mentioned here. So notice I've been a little less lazy now. I've said, okay, it's kind of saying that it is coming from the boys table and the boy ID. So remember I said names, constant names usually will say which table, which field are you referencing. So from the boys table, I'm referencing the boy ID field and I've called it FK1, foreign key 1, right? And what is it saying? What is the constraint? So do you need to have this statement at 55? No, but it's a habit. Names are always good because then you can change them. I mean, you can refer to them. So again, I won't need it in this course, but it's a good habit. So start with the good habit. But what is the rule? The rule says that boy ID is a foreign key. That's the rule. And it is referencing the boy ID from the table boys. That's what you're saying. And does it have to be called boy ID here? No, it can be called whatever you like. Shh, guys, please. I can hear you a lot. It's disturbing me. Okay. Soft if you want, but I can hear you. So does it need to be called boy ID? Nope. You can call it whatever you like, but of course this should be clean and neat. So you have to say that it is a foreign key and it is referencing. What is it referencing? What does it refer to? Where is it drawing its value from? So names don't matter in the sense they don't have to be same, but the rules matter. So rules have to be written correctly. Similarly comes the toy ID. The toy ID says, oh, I have a constraint too. I'm drawing my values from the toy ID in the table toys. And that's exactly what is written here. And what is the primary key of this table? The primary key of this table is the combination boy ID and toy ID. So this table is in the first normal form. I don't have any non-key attribute at all. There is nothing else. I could have added more. I could have said, how many does of this toy does the boy have? I could have added more fields, but I didn't choose to keep it simple. So it is automatically in the second and the third normal form. Because in second and third normal forms, we talk about non-key attributes. And there is none here. So by default, it is also in second and third normal. Okay. And here is the data, which doesn't make a lot of sense to anybody. It just says 13152532415 and 62. So of course, it doesn't make sense. But if you kind of start relating it, the 1 is a boy ID and 3 is a toy ID. So if you want to interpret it, all it is saying is this. It is saying that Devi has a hula hoop, right? So 1, 1 is hula hoop. So if the value is 1, 3, so Devi has toy soldiers. That's what it is saying. So definitely, if somebody wants to find this information from your tables, you don't want to print just the third table. Makes no sense. That table makes no sense to anybody. So therefore, you'll have to start saying, oh, get this information from here, match it with here, get its corresponding value, take the toy ID, go to the toy table, get the toy, and then show it to the user. So you need to combine tables now. Okay, you could combine and create tables if you like, but you don't want to do that because then you have tables and then you have combined tables. So the whole purpose is again lost. So usually tables are just displayed, results are just displayed. But that doesn't mean you can save what you want. You can always save tables if you want. When you do a select, you can always do a save. Okay. Okay. So having said that, what's this now? Oh, there's another one, toys color. Oops, I didn't realize that there were 4 tables. So the 4th table is saying that this toy ID is available in this color. Okay. Now, why did I make a separate table, or why it was a separate? Oh, this is only about colors then? Is it only about colors? No, it's saying which toy in which color. Which toy in which color? Oh, this information cannot go in the toy table because 5 is available in white also and 5 is available in yellows. I think I'm answering your question. I forget. Sorry, what's your name? Yeah, remember you were asking me, do I need an ID for the color? And I said, no, you can combine it. That's what I've done. Just to show it to you. I would prefer to have a different colors table and put my colors there, but there's nothing wrong with this. So that was what you were asking me last week. Can we do that? And yes, you can do that. So there is your answer, right? So I've done it here. Okay, now all I've done is I've kind of just selected and showed you everything. That's all I've done. So of course, some tables will not make any sense at all because numbers don't make sense till they have something associated with it. Okay. So please notice till now I was using database name dot the table name, and I got tired of it. So I in line 101 I said use this database. So if you use it, then you don't have to qualify your table names. If you don't have a use statement, then you have to qualify your table names. So whatever you like, doesn't matter. It's your preference, unless of course asked in an assignment or in an exam, so that I know you know to do it. It's your preference. Do whatever you like. Now let's start to do joins. So as I said, a few will be to start with a little boring, but you get the knack of it. So I'm showing you all the joins that are available. They're available. There's a Cartesian join, then there is an equi join, and there is a left join, there is a right join, there is an inner join. So there are many joins. So we'll go through them one by one. Doesn't matter. I don't know what you will need in other queries. So let's start with the first one. The first one is the easiest one. All it says is it says join every record in one table with the other. So it's basically a join with no conditions being checked. So it says if I have 5 here and I have 4 here, each one of this 5 has to join each one. So pick up the first record, combine it with all 4 records in the second table. Pick up the second, combine with all 4. Pick up the third, combine with all 4. Pick up the fourth, combine with all 4. Pick up the fifth, combine with all. You'll say, will that table ever be required? As I said, I'm introducing you to all joins. Whatever you will require is whatever you use. So this is also called a no join because there is no joining condition. The joining condition says everybody is everybody's friend. There is no joining condition. I'm not joining on whether you are in the same class. I'm not joining on whether you are wearing black clothes today. Like nothing. It just says everybody says hello to everybody. That's what it means, right? And this type of join is called a Cartesian join. Right? So, or also a cross join. So let's write it. So it says form a Cartesian product of the toys and the boys table. So this is how you write it. You go select, and again, depending upon what you want to select, you can either use star or you can use whatever you like. But usually when we start joining, we say which fields. But for now, as I said, it's not so important for me. So select star. Select all the fields from both the tables. Now here star stands for all fields in both the tables. Keep in mind. So you could have duplicates. It's just a cross join. Okay, from which tables? So now you mention your table names. So since I don't want to keep going back, I have these right here, and you can copy me if you like, if you're using my script. So the tables are table toys, and you want to do a cross join. And a cross join is exactly written using the word cross join. So I'm just writing them on different lines to make it clear. It depends on whatever you want to do. You can write the whole thing in one line if you like. We know that. We can always do that. And it says cross join. I don't know why it's giving. I think once I complete it, it will be okay. And the other table is TBL boys. No condition, nothing. As I said, everybody says hello to everybody. Is what is a cross join, also called a Cartesian join, also called a no join. Right? But it is a join, it is joining two tables. So the first record of the first table will be picked up and it will say hello to all the records of the second table. When the second record will be picked up, it will say hello to all of them. That's all it is. So if I have 4 in the first, 5 in the second, 5 into 4, 20 records in the second. That's what it is, a cross join. But it has a name, it's called a cross join. So you need to be aware of it. So if you could just run your script, and once I run it, then I'll only run the answers. And if it doesn't have any syntax errors, which I'm hoping not, and it doesn't. So this was your toys table. Kind of think of, see how much you have. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 records, right? There are 10 records here. And here is the boys table. And it has 6 records. So 10 into 60 is your result. It should have 60 records. I'm sure it will show me the count somewhere. See if it says how many records. Oh, it will in your here. It will at the end say it. There it is, 60 rows returned. Notice my last statement, it says 60 rows. So that's simply 10 into 6. That's all it did. So it picked up all the fields from the first table. Please notice the structure. Toy ID, toy coming from the first table. Boy ID, boy coming from the second table. That's all it did. So it picked up the first record from here and then notice 11111 has talked to every boy. So 1 has said hello to all the boys. Then 2 says hello to all the boys. 3 says hello to all the boys. So 4 and 5 and 6 and it just keeps saying. So 10 into 6 become the 60 records. If I write it in the opposite manner, I say from table boys, cross join table toys, the result is the same. I will have 60 records, their sequence will be different. Then boy 1 says hello to all boys. Then boy 2. It's just a different sequence of records, but the result grid will be the same. That's a cross join. So if you need it, you know how to do it. Okay, that's a cross join. Let's look at the other one now. Let's go to second. So I'll introduce you to each one of them one by one. It says now let's find out what toys that does each boy have using equi-join. Equi-joins are joins when you combine two tables and you're trying to join on a field whose values are the same. That's why it's called an equi-join. So if the toy ID here is equal to the toy ID here, join that record is an example of an equi-join. And this is the most common join. You usually join tables on equality, but it could be more, it could be less, but that's how you usually join them. Okay, so let's look at it. So my question from you is, which boy has which toy? I'm not interested in looking at their IDs. I want to have something like this. Davy has a hula hoop. Davy has a toy soldiers. Davy has a ball. I want that. That's the information I want. So it's not present in one table. The boys' names are coming from a different table. The toys' names are coming from a different table. And which boy has which toy is coming from a different table. So I have to have combinations, right? So it says to find out what toy or toys, I don't know how many do they have, does each boy have, and I'm saying please use equi-join. And in a way, what is an equi-join? It is a join where you're forming a Cartesian product, but only picking up those records where the values are same. So it forms a Cartesian product and then only picks up those records in which the values are equal. It's called an equal join. So equi-join is an example of inner join. It's just a special one because the values are equal. Okay. How do we write it in its full form is like this. So let's go select. Now you're only interested. This one only says I want the name of the boy and the name of the toy. So I'll say give me the boy name and give me the toy name. Right. So now I have to qualify. Now, sometimes there is no ambiguity at all. The boy field is only present in one table, the toy field in another table, so there's no problem. But sometimes it may happen that you are drawing a record, drawing a field, and it is also a part of one table, and it is also called the same name in the other table. Then you'll have to qualify. Here I am okay. Okay, so let's see what it is. So it says, okay, from which tables? So one table was the boys table. Right? And now I'm showing you how to write it. So an equi-join is a special type of inner join. So you go, and I'll tell you where you can go a little. I mean, once we know what they are, then I'll give you the short forms of writing. And you want to combine it with table toys. Right? So the boy names comes from the table boys. The toy name comes from the table toys. But which boy has which toy? That information is coming from where? from the third table, and the name of that table is, for your information, boys have toys. If you want to go and double check, it's up to you. I thought it would be just easier if we know what it was. There it is. So here are 3 tables that I need to join. So your first question will be, which tables do I need to join? Right? And now I'm doing an inner join here. So I'm now introducing you to an inner join. So an inner join is just a special kind of Cartesian join wherein some conditions are satisfied. And what are those conditions? Those conditions are, okay, you tell me what the conditions are. So what must I pick up from here, here, and here? So I pick up the boy name from here, right? Now I look at his boy ID and I say, with what are you combined here? So 1 is combined with the 1 and 1 is combined with the 2. I pick up the toy ID from here. I go to this table and say, what's the toy for the particular 1? And what's the toy for 2? I get those and I show it. So I'm combining 3 tables, and that's how it works, right? So it's kind of a Cartesian product, but from the Cartesian product, then I'm only picking up where my conditions are satisfied. So what are the conditions? The conditions are, there are 2 ways of doing it. I'll show you both. You can use either. You can use the word where or on. So, I mean, both are allowed. Let's do on, and then I'll put in comments that you can use where also. Okay, so what are your conditions? Your conditions are that this table, just whatever we've already talked about, the boy ID from this table is equal to the boy ID from this table. So notice now, because the field names are same, there is a boy ID in both the tables, I have to qualify it. From which table are you talking about? You just can't say boy ID is equal to boy ID. It will be totally confused. Which boy ID are you talking about? Here I didn't qualify it. You could if you want, you don't have to. Because boy, the field boy is only available in the table boys. It's not available anywhere else. So you can qualify it, and some programmers prefer to qualify every field because it makes it easy. I leave it to you, whatever you like. That's my first condition. And there is another condition. So I'm just kind of, you know what, I'll write it on a different line. Then I can say you can use where also here. You can use either words, on or where, right? When you use the word inner join, usually you will see on written, but where can be used. And there is a second condition. So I'm only writing it in different lines to make it clear for you. I leave it to you, whatever you want to do. And the second condition is that the toys table, its toy ID should be equal to the toy ID of the connecting table. There it is. And there you are. That's how you do it. So whatever makes sense to you, you do whatever you want. Like write it however you want. In the beginning, I'll try to be a little, more verbose, like in more lines, and then once you understand it, then we can put things together. Okay. So you can use on or where when you use the word inner join. Just so that you know there is an easier form. And this is an example of an equi-join for your information. Why? Because it is an inner join based on equality. That's why it's called an equi-join. Okay, so this is an inner join based on equality. So you use the word inner join and you give your examples. So there is an easier form, and I'm sure you will like it. And that easier form is this. So I'll copy it. So there's an easier format, I should say. And we will stick to that easier format maybe today itself or starting from next class. You don't have to mention the word inner join. You can put a comma. You can put a comma. But when you put a comma, then you can't use where on. You have to use where. Right? So it makes it easy. You don't have to write inner join. So that's the easier form. Instead of, but you cannot use. So if you want to make a note for yourself, you cannot use on. On can only be used with where. So in the first one, you can do it. You can either use on or where when you use the word inner join, but when you start using comma instead of inner join, then you can't use on. You have to say where. And it will work the same way. right? Try it out. So some boys, which toys? So we know a few examples. We don't know all of them. So we'll run these two. Both should absolutely, of course, give me the same answer. We've already done the cross join. So there it is. Right? So basically, and of course, you can always order it if you like. Nothing stops you. You can do whatever you've been doing till now. Grouping and having and order and whatever. Everything works. It's just a select statement. Right? So this is my first table and this is my second table. So Richie has hula hoop. Davy also had, oh yeah, Davy had toy soldiers. Right? So it has picked up Richie, hula hoop, beaver, and so on and given you the result. And both have, of course, the same result. Right? So that's what an inner join is. So an equi-join is a special kind of inner join in which your conditions are equal. Right? You're working with equality. That's why it's called an equi-join. Okay? So that's an equi-join. Let's look at third one now. It says, now use natural join. So you needn't remember names if you don't like, but they're easy. Equi means conditions are equal, right? Values are equal. So you're using equal. Now there is another one. There's another one called a natural join. So all I did in the first and the second one is I replaced the word inner join by comma, and I cannot use on. I have to use where when you use comma. If you use inner join and that makes more sense to you, please go ahead and use it. You can use either on or where, whatever makes sense to you. And as I said, you can always order it if you like by the boy name. Nothing stops you. Just add it. If you want to say, let's order by the name of the person, the boy, the name of the boy is boy, and it will work. So right now they are not. So we have Beaver, Billy, D. So they'll just come in, select in order. There it is. Right? So you can do the ordering if you like. So whatever you've learned in your selects, please don't forget them. They're all, you can all use it here, whatever you've used. Compound conditions or whatever, like anything. Even your inbuilt functions, everything is possible. It's just join, nothing else. Right? So if you want to order by, you can always do an order by. So, I mean, either put them in both or remove them, whatever you like. But it can be ordered. It's just a sequence. Now let's look at the third one, which says use a natural join. So that's another kind of inner join to again find the toys a boy has. And you'll say, now what's that? It's the same thing. I'll write it for you and then I'll show you the difference. So instead of the word inner join, we use the word natural join. And it is called natural join because it naturally or automatically will do your where. So it says, oh, you're trying to join these three tables. What's common between these three tables? Between the boys' tables and the boys have toys, the boy ID is common. And what's between the toys and the boys have toys, the toy ID is common. I'll automatically do it. It will do it automatically. So, oh, that's less work. Yeah, it is less work, but there are two conditions. One, the first condition is that the name of the two fields have to be same. Right? Only then does it know that these are the two fields I have to pick up. And two, it will always do an equi-join. You can't say anything else, not equal to, greater than, nothing. So by default, a natural join, two conditions have to be met. Right? The conditions are, the conditions to be met are, this is how it works. It picks up fields with same names. Fields, doesn't even matter if they're not related. It will just pick up the fields with the same name. With the same name are compared for equality. That's what a natural join does. Or it's not, I mean, it is a condition to be met, but you have to remember, that's what it does. Fields with the same name from tables, right? So it will just say, oh, you are here too, you are here too. It picks them up, looks them for equality and does it. So you don't have to write it. But that's exactly what we did in an inner join. All I've done is I've removed my where condition. And in the where condition, I was exactly doing this. Boy ID from the boy table is equal to boy ID from the boys have toys. Toy ID from the toy table is equal to toy ID from the table toys. You could do it. It will work. It will give you the same answer. This is called a natural join. Right? Naturally, automatically. So this is called natural join. Will of course work for only under these conditions. Fields with the same name are compared for equality. Right? It picks them up. Okay, so let's try it. We must have the same answer. So 1, 2, how many? 7 rows. And if you can remember a few, the first, I mean, I haven't ordered it, but again, you can always order it if you want to make your life easy and run it. So 7 records should come up. And of course, I recognize the bees, beavers, billies, and bobbies, and then we know David. So the answer is right. So that's your natural join. So if you would like to use it, why not? Right? Less work, less typing. But you have to remember the field names should be same, whereas that's not a compulsory condition at all, as I said. As long as the references are correct, you don't have to have fields by same name. So there is a restriction here. The names of the fields that you're trying to match must have the same name. And they're only matched on equality, equal to this. Okay, that's a natural join. Any questions? So we've done a natural join, we've done an equi-join, which is an inner join and equality, and we've done a Cartesian join. Okay, let's look at the next one. Any questions? Are we okay? Okay, let's look at a left outer join now. So there are inner joins, and we've done equi and natural. They're both inner. Now there is an outer join. Outer join comes in 2 flavors: a left outer join, a right outer join. Right? That's what an outer join is. But they only differ in the position. And let me show you an example. It says use a left order. So let me just show you what an outer join does. Oops, sorry. Let me show you what it does. Okay. First, let me show you what it does, and then we'll see how to answer this question. So I'm just giving you a normal left outer join, doing nothing, right? So this is what I'm going to do. I'm going to just show it to you. I'm not looking at the question at all. I'm just showing you outer joins of 2 tables. That's all I'm doing. Okay. So it says toys are not owned by anybody. So I'll try to give you a join where at least 2 tables have some relationship. So let's take the everything. Doesn't matter what for now. This is not the solution. It's just showing you an outer join. So I'm picking up all the fields from the table toy boys. Oops. The word from is missing, of course, so it didn't help. And I'm picking up all the fields from the other table. So look at what I'm saying. I'm saying outer left join. You have to write it, outer left join. So there is an outer left and outer in. I'll show you what it is. Okay, now table toys has some relationship with this table. It doesn't have any relationship with this table. So I won't make a join here. I mean, you only join tables when they have a relationship. So I'm just showing you how I'm going to make this relationship with this table. Okay. So the other table I'm going to use is TBL table, and hopefully it will help me. No, it doesn't. Boys have toys. Is it left outer join by any chance? Yep, sorry, it's left outer join, not outer left join. There. It still doesn't like something. What doesn't it like? What doesn't it like? Oh, the condition. How silly can I be? And you use the word on. You can't use where here. Okay, now on. So I'm trying to do a left outer join of boys with boys have toys. What's the common field? Boy ID, right? That's the common field. So do something like this. You can say, now I'll give you another easy way also so that you know it. You can call, if you like, your table boys, you can give it an alias name, TB, just because it's shorter. You can say as TB or you can say TB. You can call this table if you like. You don't have to. It's just less work. Table boys has toys. Now you can call it whatever you like. Table 1, table 2 also will do. But I'm giving it names so that it makes a little sense. You don't have to. Now the use of alias names is this. Now instead of writing the full table boys, you can say TB. Dot boy ID. So you can give alias names to your table. It becomes very handy. In join it will be very common because table names are big and you don't want to keep typing them or copy and paste. So you can give them short names. You can even call it T1, T2 if you like. But again, as I said, whenever names are given, we want names to be a little meaningful, something, conveying something. But again, you can do whatever you want to. So and the condition is that the TB's boy ID should be equal to the table boys has toys boy ID. You're saying I want to join on this condition, right? So you can give alias names to your tables. It's up to you. If you want to, you can simply say table boys here. You can simply say the name of the table here. You don't have to go this way. Okay, I haven't yet completed it. I haven't said this is the solution. I'm just trying to show you what it is, though it will kind of work. But let me show you what the answer is. So please pay attention how a left outer join works. Left outer join says that this table on the left, therefore it's called left. This table on the left is trying to find a partner in this table. That's what it is saying. Okay, it is saying this table on the left is trying to find a partner on the table on the right. If it finds a partner, spit it out. If it doesn't find a partner, for whatever reason it doesn't find a partner, then put nulls in all. It couldn't find a partner. Tell me, give me that information that it couldn't find a partner. Now in our case, every boy may not have a toy, right? So there may be some boys who don't own any toys at all. So I'll say boy number 1, talk to the table. Table has boys. Do you find a partner? Yes, spit out. Do you find another partner? Yes, spit it out, because a boy may have more than one. Then I say, do you have a partner? No. Okay, spit out yourself, but for the rest of the fields, go null. So see how it works. Do it, and then we'll come back and kind of work it out. Oh, does every boy have a toy? Yeah, seems like every boy has a toy. Right, so I'll remove something and I'll show you how it works. So boy number 1 was picked up and he found a partner in the other table, right? It found a partner. So one day we found a partner 1, 3. So combined. 1 again found another partner 1, 5 combined. 2 found a partner, 3 found a partner, 4 and 5, 6. Everybody found a partner. I'm going to remove something from the toy table to show you what happens. So this is how it is working. See how it is working. The first fields are picked up, 2 fields from the boy table, and these 2 fields are coming from your second table, boys has toys. The condition is the boy ID here should be equal to the boy ID here. And that's the condition. So boy 1 found 2 partners. 1 was able to combine with 1 and 3 because 1 is same. 1 was also able to say hello to 1 and 5 because 1 is same. 2 found a single partner, 3 found a single partner, 4 and 5. Let's try to remove something from the table. Let's say the boy 6, whoever he or she, he is, doesn't have a toy. So let's try to remove something. Okay, just for the heck of it, remove this last one for now. Remove it. So now boy 6 and whoever is boy 6, Billy, doesn't have a toy. This is my connecting table. My boys has toy table. I know that it is because there are 4 tables I kind of know now. One is the boys, one is the toys, one has boys have toys, and the last one is to do with color. Okay. So what am I saying? 1 has some toy. 1 again has some toy. Therefore, 1 had 2 partners in this table. 2 has a toy, 3 has a toy, 4 has a toy, 5 has a toy. 6 doesn't have a toy. Now run that again and see what will happen. Now see the difference. Please keep in mind, this is what we had before. 6 had a partner. And now 6 won't have a partner. Oh, I'll have to run the whole script again because I changed data. You can't just run that now. If you change data, I mean, I could have just created the same table again, but anyway. So we are looking now. Do you notice something in the last record? So 6 Billy from the boys table couldn't find a partner in the toys table. So it said, I don't have a partner. And how does it say? The fields in that table, they all come up with the null value. So now I know that this boy doesn't have a, right? Now I know that this boy doesn't have a. So now this is what a left outer join does. The left outer join picks up 1 record at a time from the left table and tries to find a partner for that particular record in the table on the right hand side. If it finds a partner, it combines the fields and shows it to you. If it cannot find a partner, then it says, oh, I don't have a partner, so it puts null values in those fields. So now we can go back and look at the question. Okay, now it says, use a left outer join to find which toys are not owned by anybody. So I want to find out information about those toys. That means it is coming from the toys table that are not owned by anybody. That means my second table to whom I want to talk is the boys have toys. So if I have a toy and that toy doesn't have a partner in the toys has boys, I want to split it up. That toy is not owned by. You see the picture? Right, so I have to now do a left outer join of the toys table with the boy have toys. If a toy cannot find a partner, that means that toy is not owned by. You'll say, how will you know it doesn't have a partner? I check the field which has null and I know it doesn't have a partner. Right, so here is how we'll work. Yes, Bradley.
I just tried commenting out the 6.2 from the insert interest data for DB boys and toys, but when I tried to run the whole script again, I got an error.
I don't know what the error was. If you've commented it out like I have, you shouldn't have an error. Did you comment it out? Put a semicolon in the 5.4, or still there is a comma there?
Hang on a second. Semicolon here, out, and here we go. Yes, thank you.
Right? Now help me answer this. So I've shown you how a left outer join works. Now you are saying which toy are not owned by anybody. So you want to take the toys table. There it is. You want to take the toys table and try to find a partner of that toy in the other table where you have this information, which boy has which toy. So you'll say, oh, that looks good. Every toy has a partner. So let's try to run this now. Let's see. Oops. Uncolumn TB. Oh, okay. Table toy ID. I'll have to just change table toys. I'll call it TT. So you can keep the previous one if you wanted. That was just showing you how it works. Now I'm going to answer this. The same concept. It's just, I just wanted to show you how the outer works before I started writing it in a more complicated form. Okay, so I'm saying now join the TT table toys with the TBHT table boy has table using a left outer join, and my joining condition is that the toy IDs are same. So keep in mind, you have to know which tables to join. You have to know what is my joining condition. Otherwise, nothing will work. Okay, now see, let's try to run this. Do we have some toys that are not owned by anybody? Yes. You see something here? These toys, Tinker toys, Etch-a-Sketch, Slinky, whatever, Kite Yo-Yo are not owned by anybody. Why? Because it couldn't find a partner. So what do I now want? I only want to pick up these records. How do I pick them up? What condition must I say? From this table, I only want to pick up those records in which the toy ID or the boy ID is null. I only want to pick up those records. That will tell me which toys are not owned by anybody. Right? So here is the result of the whole thing. But my question is only those toys which are not owned by anybody. So let's go ahead. I have to put a condition here now. So on is the joining condition. Where is what you want to now pick up. Okay, that's why we can't use where when we use the word left outer join or the word inner join. Because on says this is the condition for the join. And you can always have where conditions that work on the whole resulting table. Okay, so now what's your condition? I only want to pick up those records where the toy ID or the boy ID, either you can use either field, doesn't matter. You can use either field, is null. So I'll just pick up the boy ID because it is first. You don't have to, you can pick up whatever. Where the boy ID in this field, in this record, how do you say is equal to null? Don't forget, is null. Only pick up those records. Remember, we don't use equal, we say is null. So now look at what is happening so that you know that the answers are right. You are saying do a left outer join from the TT table to the other table. Right? I'll show you how you can use the right outer join here. It's not a big deal at all. Then only pick up those records in which this field is null. So if I pick up this record in which this field is null, I'm picking up these ones. And these ones are the toys that are not owned by anybody. Right? And only the toy name is required. So you remove the star and you replace it with the word toy. Oh, now the toy, yeah, it's only occurring in one table. I only want the toy name. It just says to which toys, just asking for toy name. So it won't show me all the 4 fields. It will only show me Tinkle Toys, Etch-a-Sketch, Slinky, Kite, and Yo-Yo. And that will be my answer, right? So let's try it now. I know what my answer should be. 1, 2, 3, 4, 5 of them. There it is. Tinker Toys, Etch-a-Sketch, Slinky, Kite, and Yo-Yo. That's a left outer join. Right? And there is a right outer join now. Let me show it to you because it's so much related. Do I have a question on right? Oh, yeah, I have. The next question is on right. Right? The next question is answering the same thing with right. I'll show you what the difference between left and right. But do I use the left join? Do I use the right join? Do I use an outer join, an inner join? The programmer has to decide, depending upon the query he asked. So I won't always say, oh, use a left join. I won't say it. I just say, I want to know the names. Here I'm helping you out because we are doing it right now. But in your assignments or in your exams, I'm not going to say use a left join, unless I really have to say use an outer join. So if I'm testing you on an inner join or an outer join, then I'll say use an outer join. Otherwise, I won't mention it. You'll have to figure it out yourself. Can I do this using an inner join? I can't. I can't. Because inner joins usually, or you could say, oh, the IDs don't meet or something. You'll have to think of something. So where will you use outer joins? Wherever you're trying to find something that is in one table, but not in the other. Outer join. So maybe you can do it using inner join. I haven't even tried because if I know there is a way of doing it, a better, efficient way of doing it, why would I go with inner joins? Because I'm sure with inner joins, I'll have to join and then I'll have to again use some conditions, right? So this will give you the names of those toys that that are not owned by anybody. You'll say, what if I just kind of reverse my tables? So I kind of do this just to show you. I'm just showing something to you. I'm not saying it is the solution, right? I pick up this table from here and I put it on the other side. And I pick up this table from here and I just change the sequence of the tables. Right? And I won't do the null right here. I'll just show you everything to begin with. And then we'll say what happens. Okay. Now you'll say, oh, it looks the same. It's the same thing. You are basically saying, I'm doing it without the null right now to show you how the results same. All I'm saying is I want to still do a left outer. Same tables. I'm using the same 2 tables. I'm doing the same on condition. I can even do the same where if you like. It really doesn't matter, right? But here, let's look at, will the results be the same? One, the first thing you have to understand in a left outer join or in an outer join is the table on the left becomes the parent table. It says, I have this, do you have this? It is asking the other table for a partner. So now a toy in this connecting table is saying, do I have a partner here? That's what it is saying. So the first one will be picked up, the toy ID 1, do I have a partner here? If yes, join. Do I have a partner here? Yes, it join. Do I have a partner here? No, it will put null in the rest of the fields. So now it is looking for a partner from this table into the other table. So there is a sequence here. There's an important sequence here. So records in the first table are being looked up in the second table. So let's try this. I have an error somewhere. No, why do I have? Oh, because I only said select toy. Okay, because I copied. I want to show you everything. Just so that you see the combination. One, you will notice that the 2 fields of the first table on the left come first, right? That's one thing. So that definitely that is being computed. And the answers are different. This is not what we got when you ran the previous query. Even without the where. I haven't even added where. And I won't get an answer because there is nothing that is null. Why? Because think of it logically. Every record that is present in this connecting table has a partner in the toy table. Why? There is a referential integrity going on here, foreign key. So what you want to do is you have to be carefully thinking, what am I looking for? So this query this is not the correct answer at all. Why? For the simple reason you are saying, Do I have something in my toy boy ID, the connecting table, that is not in the other table? That can never happen. Why? Because the toy ID is referencing, is a foreign key and is referencing values from it. How can that happen? So the sequence of the table names in your left outer join is very important. It's not as if, oh, just join them. It's not like an inner join where you're saying this comma this, or you're saying T1 comma T2, or you're saying T2 comma T1. Doesn't matter in an inner join. The end result is the same. Everybody joins everybody. But the left outer join, record from the left table is picked up and it tries to find a partner in the right table. So the answers may be same, who knows, but they will not be same. Logically, they don't mean the same thing. So definitely this is not the correct way of doing it. Be very careful. Right? Be very careful of which table to put on the left and which table to put on the right. So you can write that note for yourself. Sequence of tables. Or you can say table on left. And right have a significance. What are you trying to do? You're trying to match. Right? You're trying to match a record. I mean, you can put it if you like, from the left table. You're trying to match a record from the left table in the right table. So if the match is found, good, combines. And if no match is found, no match results in null values for those fields, for the fields in the second table. And therefore, I was able to use that null condition. You can call it the first and the second table if you like. You can call it the left and the right table if you like, however you would like to call it. So basically, table on left and right have a significance, right? Their positions. So their positions, you can say table position on left and right have a significance. There is a significance. Match a record from the left table in the right table. The matching is done from left to right. No match results in null values for the fields in the second right table. This is important, right? So definitely this is not a solution. And you saw it wasn't. So this is not a correct solution at all. It has to be done this way. If you do it the opposite way, everybody will have a partner. Because the boys have toys ID will always have a partner in the toys table. Will always have a partner in the boys. Right? Now the same query. Now if I want to write it, I want to write the same query by using a right outer join. This is how you do it. Exactly what I had actually done. The only thing is, we'll pick it from here and we'll put it here. And instead of the word left, go right. And now you're saying pick up from the right table and look in the left. So you've changed the position of the tables, but you've also changed the position of your name of your join. What isn't it like now? Semicolon there. And we only want the name of the toy there. Oops. So notice the difference between the two now. Right? It is still the same thing, but there is a major difference. The answer is still the same. The question is still the same. It says find toys that are not owned by anybody. But the major difference is this. Now the table on the right is compared with the table on the left. And it tries to find a partner. Right? So of course, again, now toys is trying to find a partner in the other one. If it finds a partner, good. If it doesn't find a partner, it will split. So right and left are sisters, like siblings. Right? They are siblings, but then the position of the tables is reversed. Okay, so you again have to be careful. I didn't say I changed the sequence of my tables too. I just didn't replace left by right. I changed the sequence of my tables too. All now I'm saying is pick up the right table and look for a partner of the right table in the left table. And I know the answer will be right because conditions are same. And where? And where? And where? Now look for the right in the left. If it is not found, TBHT boy ID will is null. Yep, that's fine. Give me a minute. We'll have to think for a minute. You are now saying join the toys table with the boys table. Join the boys. Oh God, what did I copy? How did I? Okay, so take the toys table, and try to find a partner here. If you cannot find a partner here, then yep, that's fine. So whatever I said is null. Okay, that's good. Makes sense. We'll of course have to test it out. So let's try it again. And those were 5 toys, right? Logically, it looks okay to me, but again, we always test to see if it works. Yep, those are the 5. Right, so there is kind of, I mean, you can say it quite, I mean, with surety. There is no difference between right and left except changing the sequence of your letters. They work the same thing. Boy starts looking from left in the right, and right starts looking from right in the left. There's another way to do it. Can you think, instead of using the toys table, can I use the boys table and also do it? So I try to find out which toys were not owned by anybody. So I thought, I mean, the obvious will be pick up the toys and whoever doesn't have a partner to. There is another way of doing it. Can you think of it? Using the boys table instead of toys table. It can be done that way also, now that I think about it. Because in the boys table, I have a boy and a boy ID. And I also have a boy ID in my connecting table. So I can say, did you find a partner? If you didn't find a partner, you don't have a toy. Kind of, I can do it. It can be done. I'm sure it can be done. This one came to my mind first, and so I did it this way, because we are talking about which toys are not owned by anybody. So that was more easy to, like, it's just something that came. But I see that there is another way of doing it, using the boys table. So again, if nothing is mentioned, you can do whatever makes sense to you at that point of time, but it can be done in more than one case. You can do a left outer join with the boys table also. Boys pick up, try to find a partner. You couldn't find a partner, so that toy is not available. You could do that way too. Okay, so that's done, right? So you are now being, like, it's just as I said, a little theoretical. We'll get better on it. But now you've been introduced to both the joins. I've introduced you to the inner join, and I've introduced you to the outer join. Inner join is also, like, if you don't want to use the special natural join, it's okay, you don't have to, but it can be used. And again, it can be asked specifically in the question. Okay? Otherwise, outer join comes into a left outer join and a right outer join. Okay? So that takes care of this. So the whole script should run now. The whole script should run. And the answers are right. We've double checked it. These toys were not owned by anybody. We've already checked that these toys were not owned by anybody. You can go back and see. See, they were not owned by anybody. I mean, you can double check. I mean, you always will check what is going on. But starting from, there were few. I can't remember their names now. But definitely HS, Sketch, Slinky, Kite, and Yo-Yo. So 7, 8, 9, 12. And Tinker Toys. 6, 7, 8, 9, 12. I don't see those numbers here at all. So they're not owned by anybody. 6, 7, 8, 9, 12 are not owned by anybody. So if you want, you can put back line number 73. That was just to show you an act, like I wanted to show you an example. But now if you understood what it is, and again, answers will change now. If I say 6 owns 2, so 2, actually it will not change the answer because 2 is already owned by 3 also. So I still will have the same answer, 6, 7, 8, 9, and 12. Those are toys that are not owned by anybody at all. And that's exactly what the answer I have. Toys not owned by anybody. So if you want, you can put it back. It won't change your answer, but at least then we are not disturbing the script. Like the answer will still be the same. Now if it's 6, for whatever reason, I say, oh, boy number 6 owns 12. 12 is the last one, Yo-Yo. Yo-Yo will go away from the list now, because now 12 is being owned by 6. So if you run this script again, so you can play around with it. I mean, you should. Nobody can be confident of, see, Yo-Yo is gone. Nobody can be confident of their answers till you see the solution. And that's exactly how testing is done. So a random sample of the date table is created, and in that random sample, all possible conditions are put. Like we do it in Java, right? We kind of check for all possible conditions. And if it works, then I don't have to bother. I know my script is correct, and then I can keep reusing. So I used it this way also. I told 6, 12. That means 12 is owned by boy 6. Whoever that boy 6 is, but 12 is owned. So yo-yo went away from 12. So always double check your answers, please. Always. For us, it is easy, really easy, because our tables are so small. But in the real world, the answers are checked on a sample set, and then it is done. So keep in mind, you have to check everything. Don't forget. You have an assignment in Java, don't forget. Everything needs to be checked. All methods, and within every method, all the conditions, all ifs, all exceptions that are included, everything needs to be checked. And it's important not only in Java, it is important in every programming environment. So sample data is created and every condition is checked. Is this is not present, this is present, this, and if it works, then after that you can assume it works. So my script is working, right? So again, you can put that or remove that, really doesn't matter. It really doesn't matter because we know that our answers are right. So this script is ready. So I'll put this on Blackboard when we are done. Oh, except that I forgot to rename it, but that's okay now. What can I do? Not much. I'll just save it so that I can remember it, that it's not the one that, it's the solved one. Okay, now you can pick up, let's take a break, because if I start another one, the clowns one is not so tough, but it will still take 10 minutes or so. Let's do the clowns ones because it's a little dicey. Now you can pick up, I've given you 2 of them, right? I've given you a clowns BB and I've given you a clowns with InnoDB, both of them, because there is a little difference. Okay, I can close this. You know what, let's take a break. It will take time, at least 15 minutes. Even if I do the simplest one, the clowns one is the simplest. So we'll start with clowns, and then, basically it doesn't matter. It's just more and more practice of joins. And I'll do them with you. Take a break, please come back in 20 minutes.
I'll see you next week. Yes. That your I'm all caught up except for the Windows stuff. Yeah. Feel like I'm behind 3 labs. All that stuff. Yeah, I always forgot to a snapshot. So right now I'm actually redoing the very first installation again. Yeah. Oh yeah, this is it. Oh yeah, do like this is my baby. Have you ever heard of Lebo?
Yeah.
This is Lebo based. This is like the Canadian version. I think the American version is called Sager or something like that.
Right, yeah, same.
Same thing.
Yeah.
But I gotta say it's very extremely underrated. I'm leaving the 970. I got this for how much is it? $600. No, this is actually used. Yeah. Nice 747. Dude, it's like this is the vent for the CPU. This is for the GPU right there. Yeah, so it's very optimal. Like I don't know how people just kind of like they always go for either MSI or Asus or something like that. Yeah, this is a lot cheaper too. Oh. Wait, serious?
Yeah.
Oh, okay, like I didn't know that.
Yeah. Because then it's like $100 cheaper.
But then again, I kind of stopped using Windows since semester 3. After semester 3, I just stopped using Linux. Like I don't know, I should have just kept practicing it because after a while, you just I remember I was on Python and I didn't do it for like a week or something like that. And I had really good job. Like the basic things. Like, oh my god. Like, you gotta do it every day. Otherwise it's just gonna forget. Yeah.
Or even like gaming is difficult. Like, so you can have like your VM with and then just use that like every day. And then jump back on.
Like,
Yeah, that's really
oh yeah, like I still have my Kali Linux. Yeah, from last month. So like, even though it's not it's not really a good idea to use Kali, like I've been told.
Yeah, it should be like.
Yeah.
I use like.
But Mint is probably one of the most user friendly I've found.
Yeah. Or the Debian, which is like.
The Raspbian pretty much.
Yeah, but Debian is also like grandfather.
Yeah.
Only difference is like so much more tools for like we were trying to find a solution for migrating on 6 months. Maybe like cost, but yeah, it's Debian. I use that. You see that choice.
Like I put this my oh yeah, like I found oh dude like Max to me is like dude, like say what you will about them, like about that shit, like, yeah, exactly. You know what? Like I'm fine with the price as long as you can actually get the rate. Yeah, exactly. So when you get a combine, like you get a buy it doesn't make any sense at all. It's like
mid-range,
like compared to your CPUs that that's been coming out lately, it's pretty much low. It's crazy.
and then top of the line.
Oh, dude, like yeah, dude, like I found like fucking Max period. But like there's this new new technology in laptops. But what they're doing is pretty much you're grabbing a bunch of like GTX 1070, 1080, and they actually produce the power burn about 10 to 12%.
Yeah,
Well, no. I mean, like, here's the thing. Like, up to this point, you have like a 1080s in a laptop. You gotta have like and it's even tech. I can't remember what they actually produced, but they managed to just reduce the overall performance for about 3-4%. And it's completely yeah, it looks like it's all good. Like I'm yeah. You like I slept for like an hour. Slept for like an hour and I was like, I gotta Dude, like the scariest part is I get like after like a month doing it, like after 2 years. It is. Dude, like every time somebody call me up or send me a message saying like we got a project. It's scary because like it's not like working in a restaurant where you know how long you're gonna work and you're just gonna punch it punch out. Yeah, this is like okay, you don't know when it's gonna when like the whole project's gonna be done. You don't know how big it is. A week before the meeting, the week before the event, like somebody calls me like, hey, we got a project out here. So far, bro. But like, I just cannot complain, man. Like, I cannot complain because I signed a contract and that's it. Yeah, it's I feel like I should not be doing this with this job right now. Like I hope and I didn't tell them at all. You know, I got out of school.
So they're probably like, wow. Yeah.
Yes.
Ever use it off? Yeah.
So I started yesterday. So that's why when we see green here, it means that
It has been covered.
You know what?
And if it's pink, it has been. But use JCO coverage and that will be much easier. Then you don't have to come and look at these colors.
oh yeah, it does.
Yeah, because then, when it goes to the JK coverage, then whatever is tested goes green here, and whatever is not tested keeps green. So click on the J unit. So which one are we testing? The stock market. Yeah, so I must see all green and all green.
Okay, and as you asked, I'm forcing some errors to appear.
Yeah, I want to see all the exception
All the
messages.
exceptions.
I want to see this.
See, I'm forcing exceptions.
Yeah. I want to see them. That will tell me you tested.
Yeah, so I think it's good.
Yeah.
I just have
So things are missing, it says, because I see it's not yet complete.
you don't want to see yellow, right?
No, we want to see green. I think it all goes green. And you know what? It is telling you that you haven't yet done everything. So
Yeah, so far I just have one doubt. Are you going to your office after this class?
what am I going to do?
To your office?
Yeah, sure. Come.
I just want to ask one question.
Sure. Yeah, I don't have anybody coming. Yeah, I can do that. Then I have more to mark. Okay. Yeah, sure. You can come to my, or we can do it here. Whatever works for you. Okay.
Okay.
That guy, you know, man, like the one guy that I really want to teach, like throughout the rest of the
Oh, it's cold in this room.
Yeah, like it's really fast around.
I think whoever had to come back has come back. I don't see anybody missing. Okay, so let's start. Let's go one ahead and look at now a small example that I'm trying to show you, a self join. That is, a table can be joined with itself. Till now you've seen tables are joined and that's fine. But I want to introduce you to this too, so that if you see it and if you need it, you know. Okay? Okay, so let's look at the clowns. I've given you two. Guys, can I have your attention, please? We are done with the break now. Can we start? And you can stop talking, please, all of you. Thank you. Right. So what I've given you here are two scripts. One says clowns and one says clowns with InnoDB. So the difference is in the storage engine, right? So I have different storage engines being used because I want to show you something. So what this is showing, this example is going to create a database and a table therein, which is spelling is wrong, to store clown information and to demonstrate a self join. Again, as I said, you may or may not need it, depends, but at least you should know what it is. So I'll pick up the first one first. And in here, if you notice that in the table, I've kind of done this specifically. I have made the engine as my ISAM. So this is the first one. Okay. In this one, and notice my comments, I've said, what is a self-referencing key? So look at the table. First, understand what the table does. The table is about clowns. Okay. So every clown has a clown ID, has a clown name, and has a boss. Right. So every clown has a boss. And that boss is, of course, again, a clown. Okay. So therefore, we are talking about, we need the same table. Therefore, we are saying self-referencing. Okay. So every clown has an ID and has a boss, and the boss is also a clown. And so we keep the boss ID there. Okay.
Why
So
does it have to be a clown?
it could be anything. It could be anything. Let's say students then. Okay. So that it's less funny. Okay. But now the problem with student would be the student doesn't have a boss student. Okay. So employee could be something, right? I must have picked it from wherever. Now look at this. Look at a foreign key here. It says that the boss ID is a foreign key. That means the values in the boss ID must refer to values from the clown ID. Makes sense? Because as I said, the boss of the clown is also a clown. So his value must appear as a clown ID. So it's kind of an interrelated table. And if you look at the data, The data says, okay, LC is a clown and his boss is 3. Now who's 3? So Snuggles is his boss, right? So Pickles is a clown and his boss is 5. So 5 means Clarabelle is the boss of Pickles. But what I'm trying to show you is this. 1. This is a foreign key which is referring to a field in the same table. That's 1, which is something new for you. We haven't done this. So it's referring to a field in the same table. And 2, I want to kind of now show you 2 different things. This foreign key that means I cannot have a boss that does not exist. Like Bobo, for example, if I add it, has a boss 12, but there is no clown with ID 12. The only clowns are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I only have 10 clowns. So how can Bobo have a boss whose ID is 12? Because there is no clown with ID 12. So 2 things I want you to pay attention to. One, a self-referential key. And you've seen it here. So you could have a foreign key that references another field from the same table. Of course, it should make sense. So in the ISAM engine, so that you know why am I saying one is better than the other. In the ISAM engine, foreign keys are not enforced. So it will work, but I can add a record that is referring to a field that does not exist. So therefore, we don't use ISAM, right? So in ISAM, foreign keys, it will work. Syntax-wise, it will not give any problem, but logically, it will not work. So notice what I've said. I've said a self-referencing key is the primary key of the table used in the same table for another purpose. So boss ID in this case is the foreign key. And MySQL does not enforce the self-referential constant with ISAM. Let's say with ISAM. I want to be clear. The problem is with ISAM. And I'll show you how it works. Okay. Now I did the foreign key right here itself. But again, just so that you know, like add primary key, there is also a add foreign key that you can use. So alter table, you haven't done an add foreign key before because we were not dealing with foreign keys till date. But you have done add primary key. So there is an add foreign key that you can work with, right? So notice how I've said add foreign key and I've given a whole reference. So if you don't do it here, you can remove it from here and you can do it here. Okay. Can't be that funny, can it be, Praditya? It's not that funny. I know it's Klaus, but it's not that funny. You can't stop laughing, not even smiling. Okay. So if you run this, we have to answer a question, which I haven't done. But if you run this, it should work. And here is the table. So clown number 1 is called LC, and his boss is 3, which is basically Snuggles. So there is no problem at all. I mean, I can put records anywhere. There is no sequence in which I have to put them. It will work automatically, right? And it looks fine. It says, oh, I'm okay. And now look at something that shouldn't work, but works. So now take your Bobo. I couldn't think of a name. Okay. And add him to the table. Now this Bobo guy has a 12 boss ID, and there is no 12 boss. There's no 12 clown at all. So as I said, boss has to be a clown too. But look if it works. See if it runs. So execute it again and see if it runs. And it runs. You'll see what happens. What happens? There is no clown called 12, but it didn't bother. It just said, okay, good. So see, my ISAM does not enforce foreign key constraints. So therefore, it is compulsory that when you want to work with foreign keys, that you go to the engine, you do that. You have to do it. It won't work. So I'll keep this example here so that you know that it doesn't enforce it. But you'll say, then what do I do? Go to a different storage engine. And so I'll go to the InnoDB1. Okay? In InnoDB1, it works, but it has to be done in a particular sequence. And that's what I want to bring. Only for self-referencing keys, not for anything else. For the other things, for the other tables, of course, you know, a table must exist before you can refer to it. That's, of course, logical. So if I'm saying I have a boys table and then I have a boys have toys, keep in mind, last week also I told you that, of course, if you're referencing to a field, that should already be defined because MySQL just goes in sequence. It's just kind of procedure. So it goes. So if the field does not exist, if the table does not exist, how can you say, oh, I'm going to refer to that? So that sequence has to be remembered. Similarly, this sequence has to be understood. So I won't write my answer here. I'll leave it for you. I won't even put it back on Blackboard, but notice this works, which is saying, oh, useless. What's the sense of this foreign key? It's useless. So now go to the InnoDB. So in the InnoDB one, I've kind of given my engine here because I told you, you can do it either with the table or you can put your set environment right up there. So I kind of chose this one here just because there was only one table. Same thing. The only difference is the engine, right? But now there is something very important that you have to remember when you're using self-referential keys in a table. There is something very important, and that important makes logical sense to me. The boss ID needs to exist before a clown record is inserted. That means if LC has a boss, then that information about that boss must come before it in the records. So I can't say LC comma 3. Why? Because clown number 3's record has not yet been inserted. So that's what you have to be careful about. So I can, with LC, I can only use 1 because there is nobody before 1. With pickles, I can either use 1 or 2. With snuggles, I can use 1 or 2. You know what I mean? So if I come to a record 2, the boss of pickles can be only either somebody whose record has already been added or he's his own boss. So the sequence is important. Now, 3 pickles can either have a boss 1, LC can be a boss for pickles, and snuggles and pickles can also be a boss for this guy. Similarly for Mr. Bobo. Bobo can have either LC, pickles, or snuggles as his boss, but he cannot have Scooter as his boss because the Scooter record has not yet been added. So you have to remember this. So ISAM doesn't implement it at all. So that's out, right? We can't do self-referential in ISAM at all. So I had to use InnoDB. And not only self-referential, foreign keys constants are not implemented when you use ISAM. They just don't, they're not adhered to, they're not implemented, right? The rules, it just doesn't work. So it was fine, but nothing gets implemented means it's useless, okay? But here you have to keep this in mind. You have to be careful about this. That the boss of a clown can only be a clown whose record has already been added in the table. So that's the sequence you have to remember. So this will work. It will work. It will also now, okay, it was highlighted. Looks fine, right? It's fine. And now if I try to do this, so what am I trying to do? I'm trying to now, let's try to add another Bobo here, whose boss is 12, or not even like 12 doesn't exist. You know what I mean? 12 just doesn't exist. If I try to do this now and run it again, it's going to give me an error, and please see what it says. It says cannot add or update a child row because a foreign key constant is being violated. So the foreign key constant is implemented. It is implemented, but you have to be careful. In a self-referential table, you have to be careful. You can only reference to a ID that's already in the table. So it makes sometimes become difficult. Like, I mean, you have to be very careful of how you're inserting your records. So it implements it, and that kind of tells, since it was a simple one, I could show it to you easily. And that tells you that InnoDB is the storage engine you should use whenever you're working with foreign keys, not self or otherwise, foreign keys. Now let's answer the question. Okay, so keep that in mind. So both of these scripts were on Blackboard for you. But in the second one, I kind of made a note saying MySQL will enforce it in the InnoDB engine, but records need to be inserted in a particular order, in a certain order. You have to be careful. That means, what is the order? The boss ID needs to exist before a clown record is inserted. Okay, so it has to. So the boss ID must be a valid value. Otherwise, you can't do it. You just can't. It will give you a problem. Like if you try it, even without Bobo, if I try to say 2 here, it will not work. It won't work. So, I mean, syntactically, it looks okay, but logically, it won't work. So you can't do it. So you have to be very careful of how you work. Okay. So a person who is his or her own boss has to kind of come first and then come later. Like you have to kind of work it out. So I just took a different example. I kind of made it this way. It doesn't necessarily match the first one. Now let's look at the question. So when the table comes up, It's all fine, but I have no clue who is the boss of LC. I know he's 1, but I don't want to search the table. Oh, who's 1? I don't want to say 5. So Bonzo's boss is 5, but who is 5? I don't have that answer. I mean, you can also say, oh, 5 is Claribel. But of course, to a user is not expected to look for answers. To a user, you must exactly tell the answer. So now in this query, I want to say, give me the name of the boss. Give me the name of the boss. So I want the name of the clown, which we already have, but I also want the name of the boss. I don't want his ID, like your table is showing, I want the name of the boss. So if you kind of think of it, logically, what should you do? Like, what's the solution? Pick up the boss ID and search in the same table who is 1, and that will pick up the boss. So 3. So look in the same table for ID 3 and see what is the name of the boss. So you're basically, this table is referencing itself. So you want to join the table with itself. You have to have 2 copies of the table, but you only have 1. You can't duplicate that. So what I'll do is I'll take 1 and I'll make a copy of it in an alias name and then use it, because that's the logic you need. So you're saying pick up the boss ID and look for that boss in the table, for that boss ID, and that becomes the boss. Look for the boss ID and that becomes the boss. Look for the boss ID and that becomes the boss. So we have to do a join here, but this is an example of a self join. So let's write it. It's called a self join, not different from writing join, but it's just a self join. So let's select. I need the clown name, and the clown name was clown name. And I again need the clown name because that clown name is the boss. So I need 2 clown names. One, the original clown name, and second, the name of the boss ID. So what I'm going to do are 2 things. 1, so that it's not confusing. Bless you. And 2, so that you know who's who. That's 2 things. But now comes the big thing. There is only 1 table. So what should I do? This is what you do. You go from, and now give the table name twice. Give it 2 names. So the table name was clown's information. And call it C1. Give it an alias name, C1. You can say as C1, you can only say C1. Okay, as is optional anywhere, even in your alias names here. It's optional. And make a copy of it. I mean, you're not making a physical copy of it, you're making a logical copy of it. So I'll just show you that it can be done. You can use as, or you may not use as. There. So I've used the same table, but I've said I'll make a logical copy of it. So one I've called C1 and one I've called C2. Now this clown name I can pick up from C1. Sorry. Oh. This clown one I'll pick up from C1, and this name I'll pick up from C2. Oops. That's what I said. Pick up the boss. Now see the logic. Pick up the boss ID from here, and thinking there is another copy here which I've called C2. Pick up the boss ID from here and search for that boss ID here and pick up this name. That's the logic I want to do, right? That's how I'll find the name of that boss. So you have to pick up the ID from the first table and find this ID in the second. So what are you matching? Boss ID of the first should match the clown ID of the second. How do you search for one? You take this boss ID and look for clown ID 1 in the second table. That tells me the name of the clown. You pick up 3 from here and look for the record with clown ID 3, and that tells me the name. Make sense? So what is my condition? My condition says join these 2 tables, and remember I've used the comma for your inner join. I've started using comma because, as I said, it was easy. You can use inner join if you like. And here is your condition. What is your condition? You're saying from the C1 table, the boss ID must be equal to the clown ID from the C2 table. There, that's my condition. So here is an example of a self-join, which is joining a table with itself, and of course using 2 different fields of the table. And my joining condition is that the boss ID from the first table should be equal to the clown ID in my second. That will be needed. So notice clown name is picked up from the C1 table, boss name is being picked up from the C2 table. The two tables have an inner join and there is a joining condition. This is an example of a self-join. So anytime you need to do a self-join, which you will definitely be doing in the assignment and in an exam, you just give them alias names and a logical copy of it is created, kind of, because we don't know how it works initially, but that's what happens. A logical copy is created. It's not duplicated physically. And then the conditions are matched. Condition or conditions. So does that make sense? So kind of think of you have this table and you made a copy of it. And how do I find out who's the boss of LC? So I say pick up the boss ID. In the second table, kind of thing, in the second table look for 1 and that's the name of the boss. So pick up 3 from here, look for the 3 in the other table, and that's the boss. Right? So you have 2 tables. Okay? So if I run this script, so LC is LC, Pickles is Pickles, and then Snuggles is LC. The first 3 we know. There it is. Okay, so that's another inner join. It's called a self join. So you may know names, you should know names, but like you don't have to memorize them, but what's an equi-join, what's a natural join, what's a self-join, you should know what they are. And then, of course, the outer join is a left and a right. So there is your answer. So, 1, you have to remember that foreign key constants are only implemented with the InnoDB storage engine. And 2, only for self-referential, the records to be inserted have to be in a certain order, which to me logically makes sense. How can you talk of somebody if that somebody doesn't exist? You know what I mean? Like if you're saying the boss ID is 5 and there is no clown with ID 5, how can you, I mean, how are you referring to it? To me, it makes sense. So we'll stick with this. So you can keep the other example so that you know that it is not implemented in my exam. So you'll say, oh, but there is an advantage. I can put records in any order. That's not the advantage I'm looking for. I'm trying to see that it works. I want to say that this constraint must work. Rules have to be followed. Right? And the rules can be followed, but only with InnoDB. The rules are enforced only with InnoDB. So I've used it here because I haven't done this before. I mean, I used a set statement. And again, small, upper or lowercase doesn't matter at all. Usually you will see that it is either one. Really doesn't matter. So I just, when I started typing it, it came up and I kind of just copied it. But it is the same thing. Remember, MySQL is not case sensitive. You should be aware of that. MySQL is not case sensitive. Right? So that's about clowns. We had a share of laughing. Okay, that's done. So that will go back on Blackboard. I won't put the first one. Yes, Tyler?
Why didn't you change the table name?
I didn't change the table name. Did I change? Oh, you mean the alias names?
No, like sorry, the database for the clown info.
Which line are we referring to?
Like you have clown's info, but when I try to run it, I'm getting an error for it.
Oh, you mean from one script to the other. Oh, I didn't notice it. You are right. Here I called it table clowns info in the first script. And in the second one, I just called it clowns info. Yeah, you are right. Yeah, I changed it. I changed it on you. You can just either put table in it or remove it, whatever works for you. Yeah, whatever you want to do. Yeah, I didn't stick with it. Maybe I was thinking too much of trying to make it work, therefore. Yeah, I forgot my table. You can change it. Yeah, one has the word table and the other one doesn't have. Yeah, but there's no confusion here because they're 2 different scripts. I mean, I just put them in 2 different scripts. Yeah, I forgot my TBL here. Did I forget my DB also? Oh, yeah, I did mess it up. You're right. I didn't put an underscore in my DB also. Don't know what I was thinking. Anyway, that's okay. I mean, as long as I follow conventions one way, I'm okay. Okay. Yeah, the 2 scripts have different table names. That's all they are different in. And in the insertion is very different. The records have to be inserted in a different order. So don't mix the 2 scripts. Yes.
When did we go back and forth between them? Like I thought we were working on clown.
We talked about ISAM and we said since foreign key wasn't implemented in it, unfortunately we won't even talk about it. Why should we even do it? But I wanted to bring to your notice that foreign key constants are not enforced in MyXam. That's all I wanted to tell you, that it cannot be done. It doesn't enforce it. Error. The second one, what does it say? Yeah, because you guys are not working with the right file. That's why you're working with a different file. No, I'm working with two different. Notice I'm working with two different files. I said now let's go to the InnoDB one.
That's what everyone said.
I said now let's go to the InnoDB one. I'm working with a different file. Like I said, there are two files on there, so you can now ignore the clowns BB. The clowns BB was just to show you that it doesn't, my ISAM doesn't enforce it. But to enforce it, I went with InnoDB, but I also said that you have to put it in a right order. Guys, there are two different files on Backboard. And I said two different files. Anyway, now everybody with me?
Yeah.
I think you were too busy laughing, that's why. Okay, that's done. Now let's go one step ahead, right? So that takes care of clowns. And now, as I said, it could be in any order. Really doesn't matter. They're all joins, and I'll also do subqueries with you. Because you know what? Then I can give you an assignment there where I can ask. So let me try to do both of them with you. Something that will do both. Give me 1 minute. I'm picking up an example that does both. Okay, let's do this one because this is a little more, again, theoretical rather than coming to it. So let me introduce you to everything and then we'll start doing more. Okay, so please open up my contacts _ jobs, not my contacts _ jobs 2, just the one with no 2.
Yeah, so jobs _ BB, not jobs.
Yes, 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 yes. Just introduce you again to a few more things and then we will go. Maybe it's, yeah, I want to also show you ERD diagrams today. Let me show that to you too. Okay, so maybe this will be a little more easy to follow. This is telling you about some people who are looking for jobs, job listings, and expectations and so on, right? So we'll go through the script again. So I'm back to my SQL statements because in one I wanted to use either one of them. So I'm going to create a database, some tables therein, populate them with data and extract information from the table. Right, so I have to extract information from the tables. With employee data, you can say, or with data about job data, you can say, whatever you would like to say. It's not only job, it's also about contacts also. So I'll just say data. Anyway, okay, so let's look at what it is. Normal drop, create everything statements. By this time, you all know about these. Let's start with my first table. Is it in the first normal form? Yes, I see a primary key. I don't see any field that is repetitive. I've removed, I don't have any field. Last name, single field, first name, phone, email, gender, birthday, and zip. You'll say, what is zip doing in a contact? It will help me to find out which person lives where and where is he looking for a job. Okay, that's the use of zip. Otherwise, it's just a contact ID, a last name, a first name, phone, email, gender are normal. And you'll say birthday doesn't matter a lot. The birthday to compare two persons, I don't know what I did with it. I did something, did I? I can't remember. But definitely zip, I remember what I did with it. Normal table. In the first normal form, yes. Primary key is contact ID, single field, automatically in the second and the third normal form. So this table is in third normal form, okay? I'm going to insert some data. Again, the data gives you the contact ID and everything. Plus, it also is not adding the foreign key for you. So please see that I have a list here. Many of you, I should say, no, not many, maybe half, forgot that you could use a list in your insert statement. So I'm not inserting my contact ID because it's an auto increment field. And as I said, the best way to use an auto increment field is leave it alone. Let it do its own job. That's the best way to use it. That is the whole purpose of using it, that you don't want to bother about it. Okay. So these contact IDs will be created. So you can kind of think of it as a table in which information about all contacts are there. Table number 2. The table number 2 says which contacts have a job. Okay, so this table has contact ID, which is you won't make it auto increment here. Why? Because it is going to draw its value. It's going to reference the values from the other table. Okay, so it has a contact ID, the title, the person, computer programmer, analyst, whatever, DBS programmer, the title, the salary of this person, how much he or she is taking, and let's do something. We should always say unsigned here. We can start critiquing it, okay? So not null would be a good idea. Otherwise, how would you, I mean, doesn't make a lot of sense if you don't have it. So let's add not nulls. because it may, oops, okay.
I think you might have clicked on the wrong thing.
Yeah, I did. Right, because it makes no sense that you don't have information about what the title or the salary or the date of an employee is. So I've made them all not null. Please look at the foreign key constant. The foreign key constant is called table my contacts contact ID. As I said, the name of the table from which you are drawing the value of this foreign key. That's the convention, not the norm, I must say. That's the convention. So name the table from which you are drawing the values of the foreign key. So name of the table, name of the field. So name of the table is table my contacts and name of the field is contact ID. Right? FK1 just says foreign key 1. So if you have a lot of foreign keys, you just add foreign key 1. What is it saying? It is saying that this contact ID is a foreign key because it is drawing its value from the contact ID of the other table. Make sense? How can you keep information about contacts who are not in the contact table? So you can think of contacts being your bigger table, where all in contacts are kind of adding. They may or may not have a job. So if they have a job, this is where their information goes. Okay. Okay, let's look at some values that I've put into the job current. I have some people 1, 2, 3. Oh, you know why? That's why I didn't put a null, but I have commented them out. For some students, for example, 7, not some students, some contacts, look at 7. 7 says I'm unemployed. So their title was unemployed. And therefore their salary and sale date were null. So maybe I needed it for something, and though I've commented them out now, but here is an example where null will work. And look at the student number 10. The person is a student, so he doesn't have a title yet. Though again, if students are working somewhere, they will usually have a title. But if there is something like you only say student and the title is not important, then you say student and then you go null and null. So that's why it was not null. So again, depending upon whatever you want to do, we'll kind of work around it. Okay. So since I may need, if I have them there, maybe I'll need them. I don't know. I must be doing things. And again, just to give you an example, though I've commented them out, there is nothing which has, none of the other fields have null or none. So unemployed and students are just special values for your titles. So you could add that data like this. Nothing stops you, right? So you're saying, oh, this person is unemployed, so but I still need to, then I say just remove him. Remove him from the table. He doesn't have a job anyway. You know what I mean? So just remove him from the table. He's in the contacts table, leave him there. But here remove it. Doesn't make sense. So that unemployed doesn't make sense, but the student one could make sense. So I've kind of commented them out. You can, I think you can even remove them. And then we can go back to saying not null, not null, not null. I think that would be the right way. Anyway, let's look at job desired. Table number 3 now. Table number 3 says, this is a list of what is your preference? What is the job that is desired? So some people don't have a job. And those people, or even if you have a job, you may have another preference, right? You're working as a database analyst, but you would like to be a programmer. Okay, so this job desired says that this is the job, this is the information about what would I want to be. So again, the contact ID, this contact ID wants to have a title this. So I want to be a computer programmer. This is the lowest salary that I'm willing to work with. And this is the highest salary that I'm expecting. Though low salary is what I would keep, not this highest salary. But anyway, let's go unsigned here because they should be unsigned. And then how many years of experience does this person have? You can even go small, tiny, right? I think because 252 is a big thing. So let's change that too. So as we do it, please critique it with me. And then if there is anything that doesn't make sense, ask me. You can even say default 0. That will save you entering a value of 0, right? I made a few changes. Please see that you make these changes with me. With the not null one, I'll see. If I see I don't need it at all, then I'll make them not null. Because if a person has a job, then the person has a salary and has a date of joining. To me, it's obvious, right? So I think we'll make that not null too. I don't know why I put those records. Maybe I was trying to show you something in a query, or I will try to show you something in a query, and therefore maybe I removed it. I'm sure something like that. Anyway, so years of experience, I've changed it from int to a tiny int. Completely makes sense to me because there is nothing tiny than the tiny int. Even that's more than enough. 0 to 255, right? That's more than enough. I don't think anybody can have, like logically, nobody will have it. but that's the smallest I can go. You can go bits if you like, but I don't know how to work with bits with numbers. I've never tried it, but I can always look it up. Okay, but bits are smaller. Each bit is 1 bit. So you could be saying give me 3 bits or 2 bits, whatever. Anyway, and it's an unsigned. Of course, numbers of experience cannot be negative, and I've given it a default value of 0. Okay, so makes sense unless I don't disturb anything else. Now again, this table has a constraint. The contact ID is again a foreign key, and it is drawing its value from the contact ID of the main table of my contacts. Make sense? Okay. Now let's come to what I need to insert. So 7, the poor guy 7, remember, who was unemployed, he wants to be a computer programmer. 8 already has a job, but he wants to be a computer programmer. 4 wants to be a sales manager. 10 wants to be a baker. Don't know what he is right now. 10 didn't have a job. 10 was a student. Okay. And 9 is a baker, but he wants to be a chef. Okay. So these are saying job desire. Doesn't mean, oh, this person does not have a job. It just means what is the preference of this person. So you may have 7 doesn't have a job, but still may not give a preference. You'll say, I'll take anything or everything. Okay. Then comes, what is the minimum you're expecting? You're saying, I'm not going to go below 80,000. And salary high is not saying, oh, that I can't go beyond that. It's just saying that that's the highest I'm expecting, kind of. Because if I want to be a chef, that's what I'm expecting. Computer programmer, poor guy, and the chef have the same thing. No big deal. And then comes the year of your experience. So 10, 11, whatever is how many experience, how many years do you have in under your belt? Okay. Then comes the last table, in which are the listings, just the job listings, nothing else. No contact information at all. Like it has nothing. It's just listings. So which job is available? What is the title that is available? What is the salary that is available for that particular job? And the zip. And here is where zip, I mean, you don't have to put it. You needn't put it at all. But the zip was, there's a query that I'll ask you to say, okay, which people are the highest in Ontario, or which people are the highest in Barrie. So there is where zip will come handy. Okay. So zips are basically used for finding that. I can't remember if I used birthday. I don't know why I put birthday there, but anyway. Right. So I've made it unsigned again here because salary field is an unsigned field. Okay. And then comes zip, which is a character field. Did you drop it on your laptop? That's why, you know, labs have big signs. Do not eat food. This is not an eating place. But now they don't put it anymore in these rooms because it's your laptop. But in labs everywhere, if you notice, it says so, and that's the reason it says it.
Yeah, believe me, I try to keep things like this from a distance.
I just hope it, you don't, it looks okay?
Yeah, it's fine.
Or just, you know, turn it over and whatever is in it may come. Just turn it. Sometimes I do it when I have
I'm
something.
just reading it like I've done it.
You have turned it over? Okay. No, because I usually eat on my laptop, right? So you're liable to have some crumbs there. Okay, so there it is, right? So these are just the listings. So basically people are interested in jobs. They'll go to the job listing table and say, oh, do you have a job for me? So these are just job listings. And then again, I've just made it unsigned because it made no sense making it. And it's a decimal 8,2, 2 places after decimal. So 6 before decimal. And then there is a few job listings here. So there is a job, there's a job available, a baker, a clown, a head. I mean, all these are available. So now, obvious question. Somebody is looking for a job. There is a job listing. Is there a job available? Right? Things like that. Or who earns the highest as a computer programmer? Things like this. These queries will now come up. Right? These will come up. If you kind of think of it, this is information that will be used many times. Now, before I go further and start answering queries, I want to show you something. So here are a few queries that we will answer, right? But I want to show you something, and bear with me now. Please ensure that you have your, if not, if you don't know, you have your default storage indent set to InnoDB. Otherwise, what I'm going to show will not work for you. Now, do this with me. So save this script and run it once and run it with me. So that all the database is created and the tables are created. Just run it with me. And just remember the name of the database. It was called DB Jobs. So I've called it DB Jobs, hoping if you haven't changed it, it's also called DB Jobs for you. Okay, so now let's see what I need. So what I'm going to do is I'm going to do a save as. That way. It's you don't have to do it. I'm just doing it because
to avoid confusion.
Yeah, just to avoid confusion for myself. Just because I have to put them on Blackboard again. Okay, so just run it once. And now I'm going to introduce you to ERD diagrams. Entity, what is an entity? Like a unit for which you're keeping information. Student is an entity, teacher is an entity. Here, a contact is an entity, a job is an entity. Or in other words, if you want to kind of keep simple, any table is an entity. That's what it is, right? ERD, entity relationship diagrams. And you'll say, what is the relationship? Anywhere you've seen a reference, a foreign key, it is referencing to something, there comes a relationship. Okay. So now I'm doing it the opposite way. Designers do it. They first create the ERD and then they create the script. I'm just going the opposite way because it's easy. I don't want you to do that. Okay. So now do this with me. Go to your database tab and go to reverse engineer. We are doing a reverse job. Therefore, it's called reverse engineer. So what is an ERD? I'll show you what is an ERD. So it says, okay, what is your connection? If you have more than one connections, please ensure that you're talking to the right connection. So database, reverse engineer. Go the opposite way. Your script is ready, your database is ready, your tables are ready, and now you are saying create the ERD. Usually it's the other way. You first create the ERDs and then you create your script. It's like your class diagrams in Java. So you first draw the diagram and then you create the classes. So please ensure that you have the right one if you have more than one, and go next. It says, okay, I'm connected to the database. I have a whole list of databases on your system because this is local, and I've done everything is okay. You'll say, okay, let's go next. Now it says, okay, which schema do you want to use? Whose ERD do you want to create? So mine may be very different from yours, but we are looking for the one called DB Jobs, was it? The database that we just created.
Yeah.
DB Jobs. Okay, so here.
Okay, so for the connecting to DBMS, I have check marks for all of them, or?
I don't know where you are now. It was just a database and we just had to go forward. Yes, do a next.
Okay.
Right? And then pick up the schema that you want to create the ERD for. If you're following me, it was DB Jobs for me. So I've picked that one up. So if you have a whole list, pick up DB Jobs. I mean, you could have picked up anything, but this is the one I'm showing you because this is the one that has 5 tables in it and I want to do it for you. And say next. Okay, so pick up the database and say next. It says, okay, I have retrieved all the objects from your schema and I've checked the results. So that means it is picking up all the tables. Okay, objects means tables. Say, okay, fine, next. So you should see check marks as you go on. And it says, okay, 4 total objects have been imported, have been selected. And please say, yes, import them. So don't remove it. I want to import these tables. I want to see them in my diagram. So by default, it is checked. Don't uncheck it. Okay. And say execute. So it's retrieved the 4 tables from your database. Now you are saying execute means create the ERD for me. In here, you will see they are called EER, Enhanced Entity Relationship Diagrams. Whatever it is. Okay, so execute it. And it's going to execute it and finish it. And what it has is this. You can kind of, just to see the relationships more clearly. If it doesn't do the lines, that means InnoDB is not your default schema. Storage engine. That's what is happening. Because remember I said InnoDB enforces foreign key and my exam does not. If my exam is the one you are using, instead of set, try to put that engine in your create table command at the end. If it is not, remember how we said, see it in one of the examples, in the clouds one. See how you do it. Try to do it that way. If your set statement is giving you a problem, but that's what it's the default. So I don't know why
Mine's default. I don't know.
Yeah, yours is default. So now let's look at this, guys. Let's see what it is so that you see. Do you notice? Now there are a few things you can do. This is the crow's feet. You see how there is a 1 on one side and there is a crow's feet on the other side. That's a one-to-many relationship. You can always say, and where was it? Now I'll have to look for it. Here, model options. Or here, relationship. So instead of crow's foot, if you want to go classic, try classic if you want. Okay, try the connect to columns. Connect to columns does what? Tells you which column is connected to which. See here. So the contact ID is the connecting column. So I mean, whatever you like. Some people don't like this because the lines are not straight. But what it tells me is that the contact ID from the table my contacts is connected to the contact ID of this. And see the notation. On one side it says 1, and the other side for many it says the infinity symbol. So you can try a few things if you want. The crow's feet is the default. This one shows you the relationship and also the field that is connected, even if they have different names. Especially when they have different names, this becomes very useful. But here the names are okay, so it was not bad. So you can try this. This was in model, relationship notation, and then you can try the classic if you want. Classic one makes a diamond.
Yeah, so how do I string the line so it says this, it's similar to that?
Change the relationship. I just said go to model and change the relationship notation.
Object notation.
Please look here then, Bradley. That's what I'm doing. Right? So the crow's foot was what it was. This is classic. And the connect to columns was this one. Whatever you want. I'm not saying what you want. I'm just showing you what can be done. Okay. And there are some model options also. Now, again, if you kind of, I mean, if as I said, in the notations, you can, if you don't like what the default is, you can always change it and you can start saying, oh, show me the line crossing, show me the column. So I leave it to you to kind of play with it a little. I don't want to show you what each option does, but you should go here and just say, oh, this is what it does. Okay. So the defaults work good for us, but you can always change them. Okay. So now if this works for you, good. If you don't like this notation, then you can always go back to the classic or the crow's foot. So what you see on one side, the 1, and what you see on the other side, the crow's foot is saying, there is a one-to-many relationship. So what is it saying exactly? See, my contacts, on the my contact side, there is a 1. And on the table job current, there is a many. There's a crow's foot here. And you can always go right click on your relationship and you can always remove this if you want and so on. Which you wouldn't like to do, but always do that. So you can always select it. You can always select your relationship and you can always cut it or edit it in a new tab. Edit means it will open up and you can edit it here. So we are not going to go into the MySQL way of like MySQL workbench and telling you everything, but you can always, your tables can even come here, your relationships can come, your tables can open here, and you can make changes to your tables right here in a visual window. You can do that too, okay? With MySQL, you can do much, with a workbench, you can do much more. I just don't, like, I don't do it because I don't need to, okay? So you can do all this also if you like. Okay, so now this is an ERD, and what does an ERD help you? I would strongly recommend that you always create an ERD for your assignment or your exam or whatever. In exam, I'll give it to you or whatever, so that it's very clear how the relationships are and what are the tables and what are the fields. And again, though it is not very neat, it is nice that if you can see the relationship notation as connect to columns, then it tells you which column is being referenced where. And start noticing a few more things, please. Notice how the primary key has a yellow key. That's the primary key of the table. It's yellow in color. How the foreign key in this table has a red key. So it is a red key, but it is a foreign key. So again, so all you have to do is you'll have to kind of go and say, oh, what does each one mean? And I'm sure I can't remember now, but I used to know the difference between, and I'll look it up again because you forget, right? There's a difference between the colored diamond and the one without the color. Oh, I forget now, but it will come back hopefully. If you kind of click on these indexes, it is saying, oh, it has a primary index, and each one of them has a primary index. And if you bring your mouse over it, it will tell you what your primary index is. So it's telling you what your primary key in each table is. Right? So it's quite visual. But it does help in answering queries. It makes more sense. So as soon as I say I want the name of the contact who has a job currently, so if which people have jobs, you will say, oh, what are the names? The names will come from this table. And who have jobs will come from this table. So these are the two tables I need to join. So it is very handy. I find it very handy. I'm not forcing you to use it, but my recommendation to you is to use ERD diagrams because they're all over the place. So it's up to you if you want to use it, but that's the first step. So a database designer will create these ERDs and the programmer will implement it. Because what can you see? You can see everything from a table. You know what the ID is, you know what these fields are and so on. and you will create a table with these fields. So I went the reverse way. Therefore, it is called reverse engineer. Right? Sometimes you may be taking database from somebody and they don't have an ERD and you want to create one. That is where you will use a reverse engineer. But the right way to do is first create it. You'll say, can I create one in MySQL Workbench? Yes, you can create it. All symbols are here. You can create a new diagram if you want. If you go to model and you say add diagram, you'll have an empty diagram. You can create it. You can create a diagram yourself if you want. And that's how you usually start, okay? So you can create diagrams in MySQL if you want, and you should if you want to. Or there is also Visio. I hope have you heard of Visio in probably Microsoft Suite? You can create them there also. So you have all of these here. All these symbols you need, table symbols and everything. And you will notice, it's a little advanced for you, but you will notice that there are some broken lines and then same relationship. One-to-one has a broken line also, and one-to-one has a bold line also. These are called identified or unidentified relationships. So here it says non-identifying, and here it says identifying. Identifying kind of means, very roughly I'm telling you, identifying means the second table, that is the relationship table, cannot exist without the first table. That's what identifying is, right? So again, this is for me the use. So ERDs are important. They're very important. Why? Because they are like your class diagrams or a visual representation or a diagrammatic representation of what you would want to implement in your tables. Okay, so it is important for us. How are they important? We'll do reverse engineer. We have the diagram, and now when I start answering queries, I can refer to it. So the names of persons who have jobs, name is coming from this table. Job current is that table. I'll combine them. On what should I combine them? Contact ID is the common field. I should be combining them on contact ID. So that's what will help you.
So if you create this table and then push forward engineering, it will
automatically create the tables. Yes. If that is available, yes. So that's why I said you start with the tables and then go. Okay. So if you create the table, and therefore you can create tables. So if you can create the table, you can create this diagram, and then if you go forward engineer, it will create the script for you, which is so neat, right? So that's what it is. So as I said, you can do it. Okay. Now you know what ERDs are. They are just called EERs here. You can always save a table. Okay. You can always save it. They are saved with, I think, MWD or something, an extension, but you can save them. It will ask you when you try to close it. And now let's come back to what we were doing. So this point onwards, maybe not for this one, because here again, I'm just introducing you to intersect and union and so on. But this point onwards, whenever I am working with joins, I'll always have my ERDs ready so that I can refer to them. Right? And you can use whatever notation for the relationships you like. Okay, having said that, let's come back here. So I just created an ERD for this. Now it makes it's a picture, so it makes more sense. Many of you are visual learners, right? It makes more sense. Okay, let's come back here and start answering what we have. Okay, let's get. So now I'm going to introduce you to three. Actually, MySQL doesn't even allow you to use all three, but I'm going to introduce you to three new verbs: union, intersect, and accept in a relational database, and they mean exactly what they mean in math. Union means unite them, intersect means take the common one, and accept means the normal English word accept. This, accept this, okay? So these are three verbs that are available in relational databases, or operators, I must say, they are operators. I'll show you whether they're available or not in MySQL, but how do you implement them if they are not available? Why? Because we will need them. Okay. So let's look at the first question. Now it says use union or union all. There are two of them. There are two operators, union and union all, and it tells you the difference. One will remove the duplicates and one will not remove them. It will keep duplicates to get all the possible job titles from all the three tables. So I'm basically interested in job current. What are the titles? Job desired. What are the titles? And what was the third table? It says three tables, so there have to be three tables, and job listings. So I just want to combine all job titles. I just want to pick up all job titles from all three tables. That's the field I want to pick up. So I want to pick up all the same fields, job title from all three tables, and I want to show you them as a listing. Okay. Now, if you say union, it will remove any duplicates. There could be duplicates. People are desiring a job, it's in the listing, right? There could be duplicates. If you want to keep them good, use union. If you want to remove, union all. If you want to remove them, use union. That's the difference. How will I write it? So select. What are we trying to, so that you have it from me? It's called title. Oh, let me show you something else also. This, because I'm doing it. After you do this, you can also save it in a table. I'll show you how to save it in a table. I've been saying you can do it. Okay, so select title and now go the 3 names. And the 3 names are, again, you can refer if you want. Table job current. Why isn't it showing me? There it is. So, I thought I already ran this. I did. Okay, so that's your first table. I mean, again, you can pick it up any way you want. I'll just write it in a different line. It's union. It's like a join, right? But it's easier. I don't have to give any condition or anything. I'm just saying, just pick them up. There is no condition. Your second table is called TBL job desired. That's strange that it's not helping me. And your third table is called job listings. It doesn't like something, right? What doesn't it like? It is giving me a squiggly. Syntax wise. Give me 1 minute. Oh, I know what I forgot. Really silly. Because I'm thinking about joins. You have to repeat the statement again. Because if it's giving a squiggly, that means something is wrong in the syntax. And that's what is wrong. That's what is wrong. So you're basically saying pick up the titles from the first table, or union them. Normal mathematical word union. Pick up the titles from the second, pick up the titles from the third. Now, if you only run this, you should have just a list of titles. Okay, spelling is wrong somewhere. There. Table doesn't exist. There it is. Just all titles. And you say, will I ever need it? Why not? I want to see what titles are there. That just gives me I could be joining tables and creating a new table if I want. Right? And you can do it right here. I'll show you how to create a table right here. Suppose you say, I want to keep this in a table. I want to keep all titles in a table. So again, the difference is union will remove the duplicates. I went with union because I don't want to have duplicates, and union all will keep them. Now, just so that you know, it's optional, but you can do this. What you can do is you can create a table right here and save the results of the select in the table. Right? So this is how you do it. You say create my table. Let's call it table jobs. And to be on the safe side, I'll again do it, though anybody on Dreamhost may need it. But if you rerun the script. Yes, if you want to.
I'll stick with what we got.
So I'm dropping the table just in case it exists, like I usually do. And then I'm going to create a table, and it is optional. You don't have to. I'm just showing you that you can. And all you do is you're saying create this table. All you do is give it a name, right? And you go as. See, the beauty of this is this. One, it will automatically create a table with one field title, because that's what you have selected, with the right picture clause, with the right whatever character it was. Automatically that is done. You don't have to do anything. So this is it's not a temporary table. A physical table has been created. It will join your database. If you now say show me my tables, you will have this new table in it. So this is optional. You don't, as I said, it's optional. Just to show you that it can be done. So now a table will come. It will be created. You will see that it will come on your schema on the left-hand side. Same thing. The only thing is I've created a table. So this table will be called table jobs. It will have one field called title with varchar, whatever is in all the 3 tables. I mean, I'm not changing them. I'm not saying in one titles will be of size 20, in another of 30, in another of 40. It doesn't make sense at all. You'll always be of the same size. I mean, don't try to do things that You shouldn't be doing. It's the same field, it will be of the same size, and it will be created. If you want, after this statement, to see if it works, you can do a select star from it, and it will work. Right? So if I do this, and I'm dropping it to just in case, though, of course, I don't have it yet. The table is created, right? Now you'll say, oh, it is created, but how do I see? By a normal statement, select star from table, and it will come up. Of course, nothing will come up now. These select statements are now creating a table. They won't come up. If you want to see them, what should you do? You should say select star from the table PBL jobs. And it will come up. It will show. There it is. It's a table now, right? It's a permanent table. It's not only for display purposes, it is a permanent table. So usually when we create a table, we don't give its field names and anything because it picks it up from the select statement. There is an option of doing it. You could say, oh, the titles field will now be called something else. But if you don't bother, then it won't do anything. Okay, let's go to the next one. So that's union. Union just unites all the values from a particular field in all the tables. Anything not working? Are we okay? Okay, okay. Right, so union is available in MySQL, as you can see, it works. It does work. Now let's look at the second one. Now, the second verb that I wanted to introduce to you because it's useful. These are three verbs which are so easy to use, but unfortunately MySQL doesn't. So I'll tell you how you can implement it. It's called intersect and intersect all. Same concept. Duplicates and no duplicates. No duplicates and duplicates, whatever, however you can remember them. It says produce the job titles that are common in the two tables, listings and desired. So I want to see, oh, these are the jobs that people are desiring and these are the jobs that are available in the listing. So it kind of gives me an idea what are people desiring and what's available. It would be easy if I could do it by an intersect, and in other relational databases I can do it, and the verb is called intersect or intersect all. But in MySQL I cannot, so I'll have to write my own statement. So what will I do? Join? What else can I do? Right? I have to join the two tables, job listings and job desired. Right? So now on what should I join and what should I do? So for here, you can always go back to your ERR diagram. So notice listings has no connection with anybody. Right? The job is just saying it's a table that sits alone. It says I have a job ID and these are what are the listings. And this one says these are the current jobs that are available. So let's go back. All it is doing is finding the titles. But since it is not available, it is not available. So I've kind of given the code here, but it won't work. If you kind of uncomment it, it will give you an error. So let's try to do it ourselves. Can I do it myself by doing a join since there is no common condition? Yeah, I should be able to. Joins are available, right? I should be able to. So here is the answer. I've called it 2B already. So intersect 2A is showing you intersect, but won't work. But here it is. Which desired jobs are available in job listings? Which desired jobs? So these are the desired ones. I can only see one thing that is common. Title, right? Title is common. Notice these are the jobs that the people desire and these are that is listings and they have title common. Right? Okay, so let's do it. And that's what it is asking us to do. Okay, let's go back. Okay, let's do it then. Okay, which desired jobs are available in job listings? Okay, select. If you don't want to have duplicates, remember distinct. I don't want to see duplicates. Why would I say computer programmer three times? You'll say, oh, I want to see how many people want it. Sure, then you don't need distinct. So if you want to see how many people want computer programmer, if there are 3 of them, then you know that 3 people want it. If you don't want to, then we'll put distinct. Depends upon what you want to do. Okay, so I'm going to select distinct just because I'm doing it, and we want names of tables. I'll let you know. It's called job desired. Table job desired. From this, I want to pick up the title. Right, the names I have it, so it will be easy. Okay, so I want to find these jobs. Okay, now the tables to be joined. From one of the tables definitely will be this one. And the other table will be your job listings table, and it was called job listings. And now comes your joining condition. Right? What is the joining condition? Titles have to be same. Like what else there is? There is nothing else that is common. So titles have to be same. Now, since there are string fields, both titles are, numbers are okay. Numbers are easy to compare. But since these are string fields, there may be extra blanks on either sides or whatever. We'll take care that we use string functions to kind of trim them and use them properly. Okay, so that's why we are going. Okay, so now again, you can use the comma if you like, guys. If you, I mean, I'll definitely go to commas in another class. Like I can't keep writing inner join, but that's up to you. So today, just because I'm doing it for the first time, I'll do it. And you can use on or where, whatever you like. And sometimes we use both on and where. If we want to put a condition on the joining, we do an or, on. And if we want to add other conditions, we do where. So you may need both of them, on and where, okay? And maybe, no, I won't be able to do it. Okay, so let's do on. And I'm going to use the trim function just because I'm working with a text field, okay? So I'm going to trim. And this is my joining condition. And again, I'm going to use trim. And this is my other one, except that this is from job listings. This is how, this is how you will create an intersect in MySQL. This is how you will create an intersect in MySQL. Oh, let me show you something else also. You may like that too. What doesn't it like? Oh, the word join. Here, there. I'll show you an alternate for it because it's really handy again. Let me show you an alternate. As long as you use the word inner join, that's important. You have to use the word inner join. So some people say it's the same thing, but this is something you can do. You can say using. Instead of saying on trim is equal to, like writing the whole condition, if the field names are same, you can do this also. Oh, it doesn't like it. Oh, because I have to this. No, I thought so. Yeah, it does. It's fine. MySQL can use using also. There's another way. So using title means take the title from here, take the title from here, and they should be equal. So it's kind of a equi-join, right? Without writing the whole condition. Of course, you could have used natural join also in this case. You could have, instead of the word inner join, you could have used natural join also. Here, take another one. So I'll do everything and then I'll leave it to you to choose whatever. Remember, we had that natural join. If the fields are of the same name, in our case they are, you can use natural. Answers of all these three must be the same. So choose whatever makes, I don't know, not whatever makes sense, whatever is easy. But using is something that's used too. Easy, like it's just saying using title. But I'm sure, I'm almost positive you can't put a comma here. You have to mention the word. This is just syntax. Yeah, you can't. You have to put the word. The word inner join has to be put. You can't put commas, okay? So you can use using and it is the same job. Title from the first is equal to title from the second. Run all three of them and it should work. So what are these? Job desired and in job listings. We'll double check the answer once we have it. So baker and computer programmer are jobs that are desired also, and I think I know it. Remember we said this student and this needed. You can double check. So job desired and job listings. So the data in job desired, just because it's easy, job desired, computer programmer, sales manager, baker, and chef. Baker and computer programmer, what are we getting? Yeah, baker and computer programmer. If you had not written distinct, try removing the distinct, guys. Just try removing the distinct. See what will happen. There were more than one person, I think, looking for a computer programmer. I could be wrong, but I think they were. Yeah, there were two people looking for computer programmer. That's the difference between using distinct and not using it. Similarly, intersect and intersect all, okay? So you may or may not use distinct. It's not a rule that you have to use distinct. So you can write it for yourself. Distinct is used if you only want to see it once. So whether you have to use it or not will depend upon the question, right? Maybe you don't want to, and then you want to count how many computer programmers were there. So I can put a count function in front of it and do, I mean, I can do so much. I can combine everything I've learned now. Or intersect in MySQL. It's a join with a condition, right? That's what intersect is, common things. And lastly, the third one. Again, MySQL doesn't have it, but it's called except or except all. Same thing, duplicates, no duplicates. That's the difference between alls and without alls. It says except simply means, like the English word means, give me the titles that are desired except the ones that are not in listing. So it says a list of job titles that are in job desired but are not in the listings. So I'm looking for those desired jobs that are not yet available. So somebody comes and says, oh, I'm looking for a computer programmer. I say, okay, let me check my listings. I see the difference. I say, no, there is none. You know what I'm trying to do with except now. Okay. So here is it. It says a list of job titles that are in desired. People are looking for it, but they're not in the job listings. So normal English except. And so if you use it, that's how you use it. There's also called minus. Oracle also has minus. Unfortunately, MySQL has neither except nor minus. So we'll have to do it ourselves. What do you think? What will I need? How can I do it? Think about it. How can I do a kind of a minus in MySQL? We just talked about it before break. Something that is here but not here. What should I use? Which join? Inner or outer? Remember the outer joins? Something in the first table but doesn't find a partner in the second table. So you have to use an outer join. So we'll have to use an outer join here. So I have to do it in, I mean, I have to do it. There is no option, but I have to use an outer join. So let me write it for you. So basically jobs in desired, but not in listings. Jobs in desired, but not in listings. So a partner, somebody here, but not here. Okay, so let's do it. This is the last one we'll do today, okay? And then after this, I'll kind of go, just keep doing it. Okay, what do I want to do? I want to select titles. Okay, so select the title from which table? God, in table desired. So take your table name. Okay, I want to pick up those titles, right? Because it only says titles, a list of job titles. You could start with star and do it, but that's okay. Now from where? From the table job desired. Left outer join. I'm thinking this is how you'll do it because so it's here, or is it the other way? It's here and doesn't have a partner here. So those are, yeah, I think that's fine. It looks okay to me. And then take your listings. And again, you can give them alias names if required. Okay, what do we want to do now? So you have here and you don't have it here. So that means if you have it here and don't have it here, you will have null in that field. Oh, what isn't it like? Oh, I haven't completed it. What is here and what is not here? Okay, I think we are good. Okay, what's your condition? From this left outer join this on. What is same? Titles are same. Wherever you see a minus or an except, this is what you'll have to do. There's your joining condition. Remember, joining condition comes with on. You have to be very careful about these ons and wheres. And now comes where. Okay, remember the null ones. Anything that doesn't have a partner will have null in the other table. And from the other table, you can pick up whatever you like. What is in the other table? Let me see the fields in the other table. There is a job ID in the other table for sure. That's the outer join we just did. You can do the same thing with right outer join, of course. Just interchange the table names. Is it making sense? See, I want to do what? Why did I think I needed a join? Left outer join, the first thing, outer join. Why? Because you're trying to find something that is in one table, but not in the other. So it's always an outer join. Now, which one to put where? Which is my left table? Excuse me, which is my left table? Which is my right table? I want to find partners in the records in this table. Do you have a partner? Do you have a partner? Do you have a partner? Anything that has a partner is in the job listings table. But a record that doesn't have a partner will have what? Will have null in the other one. Will have null in the other one. So that's what I've said. And you can pick up whatever field you like. I just picked up job ID because it was the most easiest to pick up. You can pick up any of these fields: job ID, title, salary, zip, whatever you want. You'll say, to me, title is making more sense because job ID is not even in the picture. Say title, make whatever. All fields are null. Pick up whatever field makes it more easy to understand. So I'm saying, take the job desired table, try to find a partner for a record in the other table. If you find a partner, that means it is in the job listing. That's not what I want. If the question was opposite, that's what I would have wanted. I could have said is not null and it would have worked. But here, so you see, I can, instead of an inner join, I can always use an outer join by saying is not null and pick up the records that match. I can even do that. But here I'm saying pick up those records that do not have a match. So the records that do not have a match will have that field equal to null. And you should have everybody who it is in the desired, but not in the listing. So leaving these two, baker and computer programmer, you should have the answer. So sales manager and chef. Right? So there were 5. There were 5 people who were desiring a job. 3 have gone in that table and 2 have come in this table. It works. You just have, so as I said, you could, here I'm saying is null, in the other one you could have said is not null and it will work. It's just a thinking process. It's just a thinking process. Now, since it was just your first day, there is too much, right? There is an equi join, a natural join, a left outer join, right outer join, a self join. There's so much that you did today, but as you start working more on it, you'll become better. You'll become better. Then you will say, oh, is this better or is this better? Should I be using this or should I be using this? You'll become better. Okay, you will. Take my word for it. Though just in the last 2 minutes, I can show you something else which may make more sense to you. I'm going to use a subquery. Select the title from this table. Select the title from this table where this title is not in this is an example of a subquery. Some people find it simple, but you know what? It is not always efficient. It takes more time. It's more easy to understand, but it's not always efficient. If you kind of go and read about, if you start comparing joins and subqueries, there is a lot of talk about what is efficient and what is not efficient. Subquery says it is doing 2 queries in a way. It is first trying to find out the titles from the job listing. So that's one query done. So one query. And then it is saying, now go and do a query on the other table and pick up those titles that are not in this table. This is an example of a subquery. It is called a subquery because there is a query inside a query, a select inside a select. So you will be doing subqueries also. So all that I'll do with you is I'll always give you joins and subqueries for the same question so that you can relate it. Right? So if you run this also, it should also run. You should have the same answer. But that's an example of a subquery. Just wanted you to see it. Right? So that's the preliminary introduction to names and joins. So some names also, right? Union, intersect, all these operators also. And now we'll start doing examples. As much time as I can devote in the next 3 weeks, I'll do as much examples as I can gather from wherever I can. Okay, so what we have left today, we'll do next week. We have the beer scripts left, we have the sports, and I'll get you more. I don't think we'll be able to do more than that in a week, but I'll get you more. Because this is all you have to practice.
My contacts jobs _2.
Oh, there's another one. Okay, so yeah, so next week you will require the same files. Okay, I don't have to make any more files for you yet, but I'll get more of them. Okay, so that's complete, and I'll put this on Blackboard for you guys. I don't know when it will come down because I have to do a few things before I do it. I have no clue. In class assignments, I don't announce beforehand and I don't know about them. If they come, they come. Otherwise, they maybe take home, depending upon how much time I have. Okay.
do we save the changes to the ER diagram and my?
Yeah, sure. If you want to, you can save this ERD diagram if you want. When you close it, and if you try to close it, it will say, do you want to save it? And then if you say yes, it will save it. And it will be in a file with MW, some MWD, I think, or whatever. It depends on you what you want to do, okay?
The ER diagram.
Yeah, it is the EIR diagram talking about. I just call it ERD. They call it EER.
Yeah, I know, entity relationship diagram, so I just called it ERD.
But you'll be creating that for so many of your.
Yeah.
So how will you know?
Okay, so the ERD we created was for my other job, so yeah, DB jobs ERD. That'll differentiate.
See you tomorrow, Chase.
Yeah.